So the next 3 presentations, hopefully you find some value on it. Our membership, the Geotechnical team membership, voted for these 3 presentations. So if you have any complaints, just talk to your Geotech members about this presentation. Good news, we listened to you guys. Last year we did some experiments, we tried to show some videos, and it was unfortunately not successful. I know a lot of people fell asleep, it was very boring, so we changed this around. Promise no videos this time, okay? Intro now, the first speaker is gonna be Soheil. I don't think I need to read his background, he's amazing. What I want to say is just that he's awesome. He provides so much expertise and help us out in so many fields, including pavement engineering, non-destructive testing, and geotechnical engineers. So at the national level, he's an icon. He's the chair of I don't know how many committees. I lose track of how many AKGs, and you can talk more about it. But anyway, he's great, and we are in good hands. Hopefully, you learned something about this project. It's very difficult. I have attended presentations about this topic like 5 times. I'm still trying to learn, but it shows that sometimes research gives you results that you're not expected. Sometimes you target the development of a device, and sometimes that device doesn't work, or is in the too early stages of development. So with that, Soheil.
Yeah. He didn't introduce me, it was something else. I don't know who was introducing. Thank you. Okay, this is on the category of gold but goodies, right? Yeah, appreciate those who voted for this, we do a lot of compaction, and I guess this is the first section on geotech side, right?
Yes.
Better? Good, thank you. Texas fellows, are the best. Around 10 years ago, maybe 12 years ago, we had an NCHRP project on how to go mechanistic foundation, the foundation of the roads, that bases and subgrades and things like that. One thing that we found, one of the major findings is that there are 2 moisture contents that matters. One, when you build it, and the other one is when you measure it. Well, yeah. So goal and the recommendation was make these 2 as close as possible, if you can. So we realized that it's very important to have a continuous measurement of the moisture content when you're doing it, and that's where this project started. I just want to acknowledge Mark Baker is a partner of mine for the last 35 years, and he is an electrical engineer who got a PhD in geophysics. And I'm a civil engineer who pretends to know geophysics. So we are working together. And all the hard work is with Isaac Zuniga and Sebastian Morales, 2 of our graduate students over here. And of course, thank you to the TAP for listening to us. Okay, how do you go? Oh, that one?
No, it didn't work.
No. Maybe this one would work. I guess we are frozen.
Always looking for trouble.
I wish Mark was here. He's an electrical engineer. He can do something. Okay, sure. So given with that background, our goal was to just put a breadboard of a device, and this is not even prototype. Breadboard is before prototype, right? Of a device that continuously measures moisture during the pavement foundation construction. Have that in mind. And a good example of that is basically the asphalt roller density measurement device, that it's very common now for the airboys of asphalt. The same concept. So there are several current equipment. These guys do a good job to tell you if you have moisture or do not have moisture. But have that in mind when we are building a space or a subgrade. We are talking about 1%, 2%. We are not talking about wet or dry. So these are available again, and they use it in agriculture quite a bit, but it was not giving us the accuracy that we need from this. So this is what we start looking at it, and something called a complex resistivity. Resistivity, I guess, is available. It's complex resistivity to measure it. And when I say breadboard, that's what it is. These are low-cost equipment. That one, the laboratory to start to calibrate, and this is the field, the rolling system that we put together to see how it's going to go. Why complex resistivity? It's basically a proxy for stiffness and moisture, because we know that moisture changes stiffness. So that's one good thing. We have a lot of experience with resistivity into the embankments and things like that. And the main one is that I guess I promised not to show you equations. The fundamental equation of the moisture suction and complex resistivity is essentially the same differential equation. We're not going to solve it today, but so the same principle that controls the moisture suction that we want to know is the same principles that works with the complex resistivity. So if you know the degree of saturation, you can do a lot of good things, but it's not easy to measure. So what is it? Those guys who do the master curves in asphalt, please wake up, huh? Okay, so what we are doing, we're just basically injecting electricity into the ground, and we measure two things, the magnitude and phase. So does that sound familiar, master curve? Okay. And then what we would do, we would just change the frequency and just follow the phase and the amplitude that we are getting, the magnitude that we are getting from the resistivity. Now, there are some things I'm going to talk about relaxation frequency. Now, all the earthquake engineers wake up. That's basically the resonant frequency that you have where you're going to get the peak. I'm showing you a broad band over here. You see two relaxation frequencies. So the goal is to take this one and try to make the moisture count. So we have a really wonderful team of TAP members. The originally was just to relate the resistivity to moisture content, but they said that, hey, you're just making up these specimens. Don't just get the moisture content. Run some strength and modulus and tests like that. And so we did some dielectric constant measurements, some resistivity, traditional and complex, and the goal was to integrate this one into getting the moisture density curve. So we prepared moisture density curve specimens at different moisture, and we just ran a resonant column for the modulus and then unconfined compressive strength. And then John Sigmeyer showed up and said, why don't you look at the LWD as well? So we did that. That one has a different size specimen. That's a 6-inch by 8-inch specimen. And then just to simulate the field, we just started making these drums and built materials within it, so that it's a different compaction method and so on and so forth, so that we can prototype it in the laboratory. We got 6 different soils, 2 clays, 2 sands, and 2 gravel. And as you see, they are diversified. Plus, we started with mixing one of the clays and one of the sands, and to see what the proportion does to my relationship, because when the soil is contaminated, you have to look at it. So this is what it saw. We were not very happy with the dielectric constant. It was just basically relates a lot on the contact area, and these are triplicate specimens. We are getting dispersion in the results. You see there's a relationship between a nice relationship. It vastly varies depending on the type of material that you have. So there is not one relationship, but nevertheless, they're related. The only one that we could not get good results was the gravel because of the size of the aggregates and the size of the specimen. We could not get. Unconfined compressive stress, again, you see that, there are different depending on how much sand you have, how much clay you have, how much other materials you have. They just have good relationship, but it's very material specific. Two clays, you see that they're significantly different just because of the nature of the aggregates. That they have. So let's go back to resistivity. So we started looking at the moisture content versus the resistivity. CL1 and SM, those are the two sands, and 4-inch mold. It means that we prepared sample in 4-inch molds. That barrel 12 inches, it means that we put a lift of the material and just test on top of it, and then we put another 12 inches and test it. That will be 24, so that we can see the interaction of the different layers. And what we say, we were pleased, things are lining up for different materials. I'm showing you a sand and a clay over there, and you see that they are lining up reasonably well. But when we started looking at the gravel, you see that there are good relationship, and the barrels are repeatable, but there is a shift between the two, between what we get from the fracture samples and we got from the laboratory. So what's the reason for that? Is just basically, again, the master curve guys, what happens, the relaxation frequency is significantly different depending on the size. So for the clays, they were long, and the sands, we were making 4x8, they were long enough that, we would see a little bit of end effect. When we went to 6x8 for the gravel, we are just to see that end effect. And this is something that is just trying to explain why the difference is. And this is the theory we use to come up with a correction factor to go from the lab to the field. The next thing is, again, I told you the inspiration was some of the work that Rosemary ignited at geophysics. And we want to go to the suction or degree of saturation. And there's always a pesky thing that to get the degree of saturation, that's the specific gravity of the material. It's very difficult to get the right number, and if you don't get the right number, then you have it. So we came up with a normalization. We call it the poor man's version of the degree of saturation. On the x-axis, normalized moisture content is the actual moisture content minus the OMC divided by OMC, optimal moisture content. And the same thing we did it with the modulus or the resistivity. Resistivity at a given moisture content divided by the resistivity at the optimal moisture content. And that was very good, because when we can start collapsing the different types of material into one curve. And so you always see that at 0 normalized is the OMC. You are always getting 1. And then you see that they're relatively collapsing into one curve. Now I have the normalized traditional versus the normalized barrel. The shape is reasonably the same, so I can do some local calibration in the field after I get the numbers in the lab, and then now I can predict the moisture content. So what happened next? We just went to the field with this was the first version, and we were not very happy with it. Then we built the second version, and this will be a little bit more happy with it. But we have a problem over here. We got a little bit disappointed. What is the problem? Because of the distances, because we want to see lift-specific moisture content. You don't want to see meters of soil. We have to have a small contact area. And when you go to the real construction, the contact area, it's rough there, and so on and so forth, and we could not get it. So we see a lot of polarization and anticipate the directions that we really didn't like. That's what we are doing. The trends are there. Going to 1 or 2%, we could not see. So we started doing some diagnostic to see what it is. So the electric contact was good. So I'm putting electricity in, but the contact area is very variable. So now I'm just the focus is different. So we looked at different directions and speed and so on and so forth. One thing that we saw at the main road, they are using wrap. They're putting 25% or 20% wrap in the mix. Well, the way we calibrated in the laboratory, we didn't have the material. We did it just with the base, and then on wrap, you know, it confuses the is it liquid? Is it solid? What is it? You know, so we have a problem. So this was the good work great in the laboratory, but you know, you just go to the field and you know, well, you have a problem. And we did a lot of diagnostic afterwards. We were not too embarrassed to come and say, give us a phase 2. You have one chance to have a good expression. So we did a lot of work trying to see what's there. So we just concluded that if we can make the wheels bigger configurations, but then we would not see the top layer alone. Or we can go smaller contact for the distances that we need, then you know we cannot get even pressure and even factor. So we started looking at some of the alternatives, and basically we decided that it's a way to go to measure the capacitance. Again, I'm not going to show equations. Capacitance is 1 over resistivity. So we can that way we can go non-contact. So we are working a little bit with that one and see if we can go non-contact and measure the electricity. So that needed a significant hardware prototyping that Mark is working. Mark moved to Alaska, he retired, and so he has plenty of free time during the winter. So, and then we are just trying to revive it again. Sorry to be optimistic at the beginning and pessimistic, but hey, it's good to know your limitations. But you know, hopefully we're gonna have a prototype to see what we can do. I'll be glad to answer any questions. You know, I tried not to show any equations. It's lunchtime. Yes, sir.
GPR and nondestructive testing. Can you use GPR to get
we look at that. Actually, we have a GPR. We have an array of GPRs. And the problem is that it works perfectly when you have a layer of asphalt, when you have a smooth layer. When you get it on the dust, it's just as bad as what we had at prototype. Okay. So if you want to know after the fact, it's great. But during the construction, first of all, you need some time for the things to become more stable, moisture, and then that's correcting the data and things like that. You know, it needs a PhD or two to analyze the data. You cannot automate it. So I hope I haven't insulted the GPR guys. I appreciate your time. Thank you so much.
Right, next is another awesome researcher, Bora. Bora is a faculty from Michigan State. You want this one first? Oh, the man is dead again.
First, we go get the guy.
He will just like, he has a special touch. There you go. Woo. Oh man, I'm getting nervous here. This one. That one? Right. All right. Bora professor from Michigan State. Again, an amazing collaborator. Worked very closely. I cannot thank him enough. I'll give you a small example of all the many works that we have done together. We are recently having a lot of issues with recycled concrete aggregate used as a foundation material. And we call him, we need some help doing this analysis very quick. He responded right away. So I appreciate all your work and helping us out. These two next presentations is gonna be hopefully not bothering you. Hopefully people will stay awake and probably engaged. because he's going to be speaking in the next two presentations, and all are related to recycled materials. In one, he's going to be talking about recycled asphalt and how to estimate properties for doing the design, doing mechanistic analysis for wrap materials. And then the second one is the one that we were talking about, RCA, very high-profile project right now. But he's going to be talking mostly about mechanical response, not environmental response on recycled concrete aggregate. And with that, Bora.
Thank you, Raul. Thank you, Raul, and thanks everybody. Thanks for the nice words, but really it is an amazing group I work with. I have amazing engineers under my research program and amazing colleagues from MnDOT and all other NRRA DOTs. So that's the main thing for success. And NRRA is one of the agencies really opened a lot of doors to me when I was a junior faculty. I was struggling with funding, and NRRA didn't care my experience or anything. They really gave me quite a bit projects when I was a rookie junior faculty, and it opened a lot of doors to me. And similar things I would say, I always acknowledge these three agencies, NRRA, MnDOT, LRRB, and Iowa DOT, IHRB in the beginning of my career 10, 15 years ago. They really opened a lot of doors to me. Okay, my bad. Thanks, Laura. Again, acknowledgement is the most important thing in my opinion. So I always had to do this because I owe a lot to these agencies and NRRA in particular. So thank you very much. These are the list of TEP members and our research team. And Sinan, if I say anything wrong, you're heavily involved in this one too. So feel free to chip in. So this was really kind of started as a literature review project that we wanted to collect a lot of data, especially mechanical, hydraulic, and related index properties on previous studies that were conducted by other researchers, especially with the DOTs that were involved in NRRA at that time. Specific focus was on recycled concrete aggregate and recycled asphalt pavement. Peter Taylor mentioned it in the morning a little bit. We had to change. I will keep using recycling word in this presentation, but recently we have to change that name and use repurposing instead of, because we just had a pool fund that was about to be canceled unless we change the name. So we need to use repurposing instead of recycling in the next future grants and all that, anything that is federally involved. So just a general information to everybody out there doing recycling work. So, basically what we, okay, so Lev touch bases with this payment ME takes a lot of inputs, and one of the main inputs is the material characterization, material properties that are very important, that you need to really have a good information about your materials itself before you start running the pavement ME analysis. And the main material input in this study particularly we focused on is the base layer, base course layers. So we collected whatever information that we can find out there that can be used as an input in pavement base course systems. And the two specific range of materials that these are some of the materials and pavement foundations that are being used, but the two main one that we will be focusing on is the recycled concrete aggregate and reclaimed asphalt pavement materials or recycled asphalt pavement material. And these are the input data that we try to collect. As you can see, resilient modulus is one of the main input that needs to be used. And California bearing ratio, permanent deformation, shear strength parameters there, and hydraulic conductivity. And it was surprising to find out that there is not enough hydraulic conductivity data on these base materials. So we didn't really get much information on that. But index parameters we wanted to look into that too, because we tried to correlate these index parameters to these shear strength stiffness parameters. So it would be useful for pavement designs. And we had two goals. The first one is really the collection of this material input. So we've gone through almost 80 reports or our journal articles and all that to extract all that information that had somewhat have the data that we were looking for. And the second goal was kind of icing on the cake type of thing, some limited sensitivity pavement ME analysis by using this database that we created in the first goal to check to see how pavement performance predictions would change by changing resilient modulus or fines content input that you use. And again, these are the list of parameters. And at that time, when we were doing this project between 2020 and 2021, these were the states that were involved. Now it's expanded much more than that. So congrats to NRRA executive team to expand the DOT participation. And a lot of data here. Basically, we've gone through all these 80 some reports, journal articles, and all that, and tried to come up with lower limits for gravel, sand, fines contents, and related the minimum, lower, median, and upper limits for the resilient modulus test data, and also some other data like CBR. What are the people run a lot of tests on this and reported a lot of information, and what was that limit, upper limit, lower limit, and the median data for that. So sometimes agencies may not, or designers may not have all this data, so they can just go this summary table and just pick the number there, and it would give some sort of idea. Still, it wouldn't be perfect, but it would give you some database that you can pick numbers up. And we wanted to specifically focus on the resilient modulus data, and as you can see, I think everybody, the majority of people in this room knows resilient modulus is a stress-dependent characteristic. So the soil doesn't have one resilient modulus data. You run these tests on different loading sequences and get this box stress versus resilient modulus data. And of course, you can't put all this data as whole in your pavement ME design. You need a single value called summary resilient modulus value, and in base as an input, and with the base layers, what we use the 210 kilopascal. That arrow shifted, sorry, it should be a little bit further to the right. It's 210 kilopascal, which is equals to 30 psi of bulk stress that corresponds to resilient modulus value. Is called summary resilient modulus for your base design, and that's the MR value that you use as an input in your pavement design analysis. So in this report, in this project, what we try to do, try to correlate how this summary resilient modulus value changes with index characteristics. So can we get any relationship or some sort of correlations? And we plot these type of graphs, gravel to sand ratio versus some summary resilient modulus value, and then try to box it, try to see, hey, if the gravel to sand ratio within this range on the left, the median value that you would use is 200 megapascal. And if it is between this range, 1 and 2.09, this is the median value that you would like to, it would give you an idea. Again, I'm not saying, oh, you can use this as a perfect input and you'll solve your problem, but this would give you a starting point and good idea where would your input may work depending on your gravel to sand ratio. Similar thing where we try to get the similar information for RCA material as well. And again, these are some of the ranges for RCA gravel to resilient modulus ratio. And again, D60, we did the same thing. Again, these are the ranges that we provide, D60 versus resilient modulus value for REB material, and similar thing that we did for the RCA material as well. As you can, these are the ranges that can be helpful for you to pick your input value. Unfortunately, we couldn't really find amazing trend lines that showing with an increase in D60, you get higher SMR or gravel to sand ratio. It just doesn't work. So instead, we try to give these brackets. If your input parameter, index parameter is in this range, this is the range of resin modulus value that you would expect. And a lot of data, a lot of summary there. And we've done this for many other index properties and other soil characteristics. But I won't, if I put all those plots, it will take 50 minutes to go through all those graphs. So at the end of the day, just as a summary, really index properties. In general, I put there higher SMR if you have higher these D effective diameter size and gravel to sand ratio. In general, it is likely to have higher resin modulus value. Of course, fines content, which is surprisingly in the REP material, the fines content didn't seem to have much impact. I think the main reason is reps don't have much fines anyway, so the data that we had didn't really clarify. It's not like we changed the fines content periodically ourselves and run the test. In the literature, we combine all this, collect all this fines content data along with their corresponding resin modulus data, and it didn't seem to affect. So with rep, I think fines content is not that of a big issue based on our data. And again, these are some of the things. I won't go all of them one by one. And one thing, again, similar trends were observed with the recycled concrete aggregate, with the gravel to sand ratio, especially with RCA, we observed higher fines content, so high resin modulus. But with RCA's fines content, it can be a challenge. And with an increase in fines content, you see a significant decrease in the resin modulus values. One of the other thing with the RCA, when you increase the RCA content within your pavement foundation layer, it kind of tends to decrease the hydraulic conductivity, and it can be an issue depending on what type of conditions that you have. So that's what the study found out. Again, we did some sensitivity analysis. We created all this huge database and then wanted to do some sensitivity analysis by running Pavement ME. And again, Pavement ME requires several inputs from pavement structure, traffic, hourly climate data, and materials. And our main purpose was to create this database for material characteristics that can be used by pavement engineers as some sort of a one source that you can get your input information, and then look into we've done analysis both for asphalt and rigid pavements. And these are the performance parameters that we look into. And these are the general inputs that we used. Again, we decided these inputs, we checked these inputs with our TAP members as well. And we thought this might be representative of the NRRA DOT participants at that time. And these are the other traffic inputs that we used. And again, these are the low traffic values based on our discussion with TAP and also previous literature. When people do sensitivity analysis, they kind of play with run their tests within these traffic ranges. And these are the distresses, target value, reliability parameters that we used when we run the Pavement ME analysis. And these are the parameters that we varied, like resin modulus value. We use the minimum limit, minimum boundary, median value, and the upper boundary. And then also same thing with all the gradation characteristics, and then run the Pavement ME and look into the IRI and total riding performances for flexible pavement, and IRI and joint faulting for rigid pavements. And again, a lot of information that I don't want to bore you. I'm happy to share the slide and can be uploaded to NRRA website. These are the lowest, median, highest data that we used for rep analysis, and the bottom table is showing the input ranges that we use for the recycled concrete aggregate. And these next few slides are a bunch of graphs that kind of shows the impact of resilient modulus variation on flexible payments. Of course, low traffic had the least impact. An increase in traffic amount caused an increase in the deformation and on the distresses. And of course, one thing that was surprisingly, especially in the low traffic conditions, IRI didn't seem to be impacted much when you use the wrap, and the stiffness of the wrap didn't seem to be impacting the IRI values much. And with the total rotting, depending on the conditions, we kind of see a lower trend with an increase in SMR. We saw slight decrease in the total rotting, and RCA had the similar trends. And the similar analysis we have conducted for impact of resilient modulus on rigid pavement performances. Again, traffic, of course, it makes sense. An increase in the traffic increases the distresses. I think no brainer there. With the highest SMR and median SMR, we didn't see much difference in terms of IRI for rep. Or mean joint faulting with rep as well, but with the RCA, with an increase in SMR didn't seem to impacting the IRI, and same thing with joint faulting in the rigid payments. And I mean, these are again very brief payment analysis. Obviously, stiffer the payment foundation layer that you will have stiffer, you will have less distresses, but we just wanted to check to see the amount of data that we collect and between the different boundaries, how would that impact the performance? It didn't seem to impact the performance that significantly. So that kind of gives a confidence that the database that we created might be a good point again to start with to kind of do your designs. And again, similar things, what we've seen a significant impact of fines content on payment performances. These are the input table that we used in the payment analysis. And with this, with any of the materials, with any type of payments we see, with an increase in fines content, decreases the performance and increases the distresses of both flexible and rigid payments. And the same thing with the again the rigid payment performance, both for the rep and RCA material, with an increase in fines content in general, kind of improved caused reduction in the IRI, mean joint faulting performances. And overall, these are some of the lessons that we learned. Again, I didn't provide all the data here. Fines content had impact, one of the most impactful parameters in the payment distress predictions. And surprisingly, the second item there, some of the index property, D60 was definitely not providing any trend. But some other index properties didn't seem to impact it as much neither. And these are some of the implementations. And actually, we have some recently project that was funded by MnDOT LRRB, kind of looking into the second item there to kind of recommend to determine the gradations and summary resilient modulus values, along with drainage and other things that needs to be taken care of and needs to be studied more in detail. So these were some of the analysis, and rigid payment results were not conclusive. Lev may have much better idea about it. So, and again, rich database is created on this. So it was a good start to kind of give a guidance to the engineers, payment engineers. And again, thank you very much for NRRA for funding this study, and the technical advisor panel for being with us throughout this study, and my former MS student, Ida Gabby, and our postdoc, Dr. Çoban and Dr. Atipoğlu were really helpful, and our co-PI, Dr. Edil, was really helpful on this study. So that's pretty much what I have. I hope I didn't exceed the time much, but all right. Any questions on this? Yeah, go ahead.
Based on your experience, it seems like the PDG models are very not that sensitive to pavement foundation layers. And last question to you, and maybe left to with one of the creators. I don't know the case for the NIPE, but it seems to be that they don't look like crazy different. The results, like even if you cheat, that still is quite a bit performance-wise. NRRA, everything looks pretty much very sensitive. Can you make any comment on that?
Yeah, I think it was a struggle, and Sinan, feel free to chip in if you remember it. I think it is the inputs that we used, because we didn't use the extreme values. You know, we collected all this data from a bunch of studies, and the range of the parameters, SMR limits, a boundary limit, like lower limit, upper limits, and the medium value, they are not in a range that would have a huge impact in the analysis. So to your point, maybe for those specific ranges, it is just too small of a range for the model, and it may not provide the differences at the moment. This was 2020 software at that time. So maybe the new updated model might be better on that. Go ahead, Dave.
He shows the graphs that show the sensitivity at low, medium, high traffic. Was the pavement structure designed to satisfy its performance requirements for those?
Yes, it's somewhat. Of course, for high traffic, it was a little bit towards to the boundary of it, but we picked it exactly to your concern, Dave, that it can handle the high traffic conditions at the end of the day. Any other questions? I think I step on a cable here. Should I just unplug it and put it back in? Okay. So this is the first NRRA project I have gotten. I was an assistant prof, and I was the happiest person in the world at that time when I got an email from MnDOT that I'm awarded this grant. It was a big project, one of a milestone in my career, and Dr. Çoban, who's with Wisconsin DOT now, was the main power running all the tests and writing the reports and all that. So Sinan, if I say anything wrong, feel free to chip in. This is your basic. Sinan got his PhD out of this project. It was now almost 800-page long report. So a lot of information here. So I won't be able to cover it all during this session, but happy to share any of the reports or presentations. Again, thank you very much for all the tab and my research teammates there. So I think the motivation would be good to talk about it. One of the motivating factors why NRRA wanted to push this through, we really are out of good quality aggregates, especially in the Midwest region, especially this glaciated Midwest. The local high quality aggregates are limited, and finding a good aggregate is difficult to find in every location. So it really makes sense to get to the use of recycled aggregate materials, either it's recycled concrete aggregate, RCA, or recycled asphalt pavement. And also sustainability has been a hot topic and important topic at that time. And you want to build your pavement in an economical way that is environmentally friendly and long lasting. And just to add to that motivation, this graph on the right that shows the annual aggregate production in the United States from 2006 to 2022. As you can see, especially after 2006 and the major investment by the government at the time in 2000, late 2000s and early 2010 start being poured in to improve the aged infrastructure of the nation. That was one of the push that we needed to really. We have aged infrastructure, bridges, everything is collapsing, and roads are not in good shape. So there was a big push to really, rebuild the infrastructure. So as you can see, as a result of that, annual aggregate production increased significantly. And with this, competition comes. It's not only pavement engineers are using the aggregates, also construction engineers, buildings, dam constructions, bridge constructions. Everybody needs this aggregate. So and the sources are rare, scarce, and competition is high. So they are getting more expensive. And the use of recycled materials definitely makes sense to replace some of that demand. And as a result of this, the three materials that are being focused, that were the focus of today of this project. Again, first one is the recycled concrete aggregate, and the second one was recycled asphalt pavement. And build tests, in addition to the laboratory test, build test sites on Main Road to kind of monitor their performances for a long period of time. And this third material was large stone subbase materials. These are the large aggregates that were not crushed in small particles like other quarries that can fit into the base gradation acceptance limits that are required by DOTs. And this can be used as a subbase, so less intense, less single crushing operation, so less intense energy spending. So they can be used as a subbase material. And I'm not sure if I will have enough time to cover the large stone subbase part of the project in this presentation. But again, happy to send the slides and other information that we have. And that this graph kind of shows how the quantity of RCA and REP used nationwide. Again, in addition to the natural aggregates, there is a competition for the RCAs and REP in the industry too. So you have a lot of competitions, and but especially if you want to use it in the payment systems, you really need to understand their limitations, so how they can be used. Can they be used just like we use the natural aggregates? And again, there at that time there was information, but it wasn't as specific as what we've done in this study. And there were some limitations of the laboratory facilities, especially with large stone subbases, how to determine their gradations and their performances and all that. So this study tried to answer all those unknowns. And we had a total of 11 test sites. These are the recycled aggregate bases. We have 12-inch thick coarse RCA material, means the gradation of this RCA was coarser. And then we had the 12-inch fine RCA. Again, the 12-inch thick fine RCA, the gradation of these RCAs were more finer in gradation. And then limestone is a natural quarried aggregate that we use, no RCAs or anything. And RCA REP were the another 12-inch thick material that is mix of RCA and REP materials. And class 6 aggregate, and especially class 5Q, has a lot of RCA in it too, but it is called as class 5Q and class 6 aggregates by MnDOT and Minnesota DOT. Then we have our 12-inch thick large stone subbases and 9-inch thick large stone subbases, and 4 of these 9-inch thick large stone subbases had biaxial geogrid and biaxial geogrid plus geotextile, and triaxial geogrid plus geotextile and triaxial geogrids that were put in. Again, I'm not sure if I will have enough time to cover how geosynthetics are put between, why it is decided to put geosynthetics between large stone subbase and subgrade, but happy to talk about it after the break. And we had three main, during the break, sorry, we have three main goals. The first one was really start with the field performance. Usually we start with lab, but the project is built before we start running the laboratory tests. And we start with the construction field performance and then determine the index properties of these materials, and then did a pavement design and construction specification guideline prepared based on the outcome we get from these two main goals. Again, the content of the project was quite a bit big, and today I will mainly talk about briefly construction monitoring and laboratory testing, performance monitoring, long term, and we still have these test sites thanks to MnDOT and Ben not to getting rid of them. They are still collecting the data, so we have data last 8 years, which is not very possible if you don't have such sites in MnDOT. So we have the total 8 years of data. So it's really showing us the long-term performance of these materials. And we'll talk about instrumentation a little bit. Probably I won't have time to talk about the pavement design criteria. So these are the list of the like laboratory tests that we have conducted, index properties, saturated, unsaturated properties, thanks to my colleague at University of Wisconsin, Dr. Lykos and Dr. Edil. Unfortunately, I won't be able to touch bases with the permeability and unsaturated results in today's presentation. And we have developed an imaging tool that you can use to determine the gradation of large stone subbase materials and also determine their angle of angularity and sphericity of these aggregate materials. And gyratory compaction and abrasion test that we have conducted kind of explains actually typical LA abrasion or that type of tests are not really a good representation. You really need to run gyratory compaction, especially on the recycled concrete aggregate materials, to really simulate the vehicle load. The abrasion happening due to the vehicle load and compactor load. And these are the pictures of the materials that we have tested and used. A wide variety of materials, and LSSB, as you can see, is very coarse large stone subbase, and the other materials are pretty much the same, except of course the clay loam subgrade and sand subgrade has different gradations. Here is a lot of information here, typically, except the clay soil that we have here and the large stone subbase that we have here. The gradation of the materials were in the acceptable criteria that can be used as a base layer in pavement foundation systems. And again, we have a whole paper on this gyratory compaction, but I won't show any results. One of the things that we observed, especially with coarse RCA and RCA rep materials, compaction is important. If you try to reach out that 95% of compaction degree, these RCA materials changing their original gradation significantly. So that's one thing that needs to be studied further. Really, what is that adequate compaction degree should be? Because especially with coarse RCA, we saw this. When you apply this compaction on it, it really changes the original gradation significantly. So that some part is very important. And water repellency, with my great colleague, Dr. Daniels, we have a whole project on making the soil hydrophobic. Basically, we don't use Rain-X, but whatever Rain-X does on a car windshield, we do it on a soil with an organosilane chemical. We put it on a soil and it makes the soil basically hydrophobic, water repellent. But with RCA and REP, we also wanted to look into this. Are they hydrophilic and hydrophobic, and because depending on that, the gradation, the permeability of these materials may change significantly. And these are some of the pictures. What you do, you basically drop water droplets on top of these aggregates. And as you can see with RCAs and limestone, you drop it and it kind of being sucked into the material right away. And that means soil is hydrophilic, so it's not water repellent. But when you come to the RCA rep and class 6 aggregates, because of the binder material, asphalt binder that you have some of that hydrophobicity on the RCA rep and class 6 aggregates. In addition to having RCA, they also have a lot of rep materials. So you can see they have some sort of hydrophobicity. And what are the lessons learned from laboratory testing? Majority of these materials that we use are non-plastic and A1A materials that fit to the gradation requirement that you can use in pavement foundation systems. But absorption was the highest with RCA materials as expected, and the finer the RCA, higher the absorption. And actually, I don't know if I put it in this slides, but our absorption, we kind of put a limit for the absorption value. If it is in outside of those ranges, this study recommended not to use those RCAs. And with the asphalt binder test, the ignition method was recommended one to really get the actual rep material. Again, I couldn't show the results here, but again, class 6 and class 5Q had recycled materials in it. They had similar properties, like class 6 aggregate had more similarity to RCA rep, and class 5Q had more similarity to the coarse RCA. And we didn't get to this, but the hydraulic conductivity of the coarse RCA, fine RCA, and RCA rep was higher than the limestone. But this was before we compare, before you apply all the traffic load and all that. I think with this new study coming, we will look into the long-term hydraulic conductivity changes of these materials as well. And the abrasion limit was with when you use RCAs, that abrasion value decreases a little bit. And again, higher abrasion for recycled concrete aggregates we observed. And again, here is the water absorption is one of the parameters that we really wanted to focus on. And that needs to be limited, as we kind of mentioned with RCA and rep. We wanted to keep that as absorption value below 4.3%. And for coarse RCA or finer ICA, we want to keep that absorption value below 7%. These are some of the main lessons that we learned and provided as suggestions. And another thing with the lessons learned from the laboratory testing with RCA, there are a lot of unhydrated or rehydrated cements. When you put water in the system, it cements and can cause some drainage issues, but that's the part that you need to be very careful, and mixing that with rep can help to overcome this problem. And disintegration of these mortars on the aggregate samples is another thing that needs to be carefully taken into account when you use our recycled concrete aggregates. Similar problem was not observed with rep materials. And do I still have time quickly? Okay. How much? 10 minutes? Okay. Oh, I talk fast, I guess. Sorry, I hope you understand what I'm saying. First, I will talk about the testing during construction of rep cells, recycled asphalt base reps. We conduct actually at that time, MnDOT crew conducted all this data, institugency, moisture contents, DCP, LWD, intelligent compaction, and falling weight deflectometer tests were conducted on each layer of the test sections. And here is during construction after compaction is completed, that shows the LWD stiffness, total elastic modulus of the base layers. And fine RCA right after construction had the highest elastic modulus, then coarse RCA, and then limestone, and then RCA and rep. And FWD results kind of provide the similar trend. Of course, the total elastic modulus values change because of the loads that you apply. Fine RCA had the highest, while the RCA rep had the lowest stiffness values. And then when we get to the performance monitoring of these cells, lot of soil temperature and moisture sensors were installed at the test sites, and so we could have monitored. We were able to monitor temperature and moisture changes throughout the season, and we're still collecting it last 8. When I say we, I count myself as part of MnDOT crew. I bother them too much, so I kind of say we, but it is really the MnDOT people. I really appreciate they keep collecting this data for us still. And periodic FWD test. We did some frost heave tone settlement in the beginning, but then didn't continue that. Rotting IRI pavement distress data. And here is the plan view of one of our cells that we have the sensors on the offsite lane. And here is our thermocouples and moisture probes that we kind of put through the depth of the pavement systems. And we collect air temperature. I reported the data here until 2009, towards the middle of 2019, because we had to wrap up the task reports and the final report and all that at that time. So, but we still have the whole data all the way to the 2025. And then we look into the freeze-thaw performance. We created these isotherms, kind of determine what is the freezing period and thawing period for each of these base materials, as you can see. And we have a summary table here. As you can see, I put a note there. I know there's a lot of information, a lot of numbers there, but the thawing periods were higher for RCA. So if you have spring load restrictions and all that, and you know that you have an RCA layer under there, you may have to wait a little bit longer to open that road to the heavy vehicle, because thawing period is a little bit higher for the RCA layers than that of you see with the original aggregate materials. But the other problem that RCA don't have, the limestone, the original aggregate, it allows the frost penetration to go deeper. So it kind of RCA, we didn't get into it, but probably because of those rehydration reactions and all that, kind of act like an insulator to kind of keep the depth a little bit on the surface of the pavement systems, and doesn't allow it to go through the depth of the pavement systems. And like I said, the last FWD analysis that we published was in 2022, but again, thanks to MnDOT and their people, we still collect this data. So hopefully in the next publication, we will have the data for whole 7 years. And one thing that you can observe, how amazingly are these recycled bases, the sections built with recycled base perform. In the first 2 years, the coarse RCA, fine RCA were still overperforming. Overperforming, like superior performance than that of limestone and RCA rep. But since 2019, you can see, and all the way to the 2022, you see the significant increase in the stiffness of the fine RCA and coarse RCA material. And this is definitely that base layer keep getting stiffer and stiffer with moisture fluctuations within the pavement system. And even RCA rep start pulling itself apart from the limestone elastic modulus performances there. And we didn't do the analysis yet, but I was just talking to Jacob today if he can send the other FWD data for these test sections to us too. So probably the last 3 years it increased even further. So it shows that the real use of recycled materials as in the base layer is a good investment, and it pays out. And these are some of the lessons learned. Again, RCA's fine RCA all the time, from construction to the long-term performance, performed the best. And coarse RCA was second. Limestone in the beginning was better than RCA rep, but now RCA rep really exceeded its performance. So these recycling materials are really working pretty well at the moment. And we didn't get into the results here, but these are some of the recommendations for designs. One of the challenge might be, again, high absorption, minimize water-related issues, have a good drainage system that would be useful for it. And the next thing that we have been working, what we did actually last October with MSU team and the MnROT team and Raul from the MnDOT Materials Research Office, we start collecting Shelby tube samples. Thanks to them, they cut a strip on some of these test sections, and we were able to get soil samples through the Shelby tube from the subgrade all the way to the base layer to check to see chemically what is happening there. So we're running these hydration tests and also environmental leaching tests to check to see how the calcium concentration changes, how the pH of these materials changes. And we also, there are some environmental concerns about using recycled asphalt material or recycled materials in base layer, recycled aggregate materials. And we look into the 10 feet next to the shoulder, another 10 feet on the other shoulder. And now this spring, we will collect other samples in the back slope and foreslope at certain depths to check to see if pH of those soils when you use RCA have any impact. Like what is the pH values of those back and foreslopes to kind of show that, hey, you use these RCA material is basically concrete, it has high pH, but it has been 8 years and pH value was not even close to 8 or 8.5, which is the upper limit that sometimes EPA enforces. So, and again, thank you very much for this funding to National Road Research Alliance. This was the first project and kind of opened the door to me when I was a rookie junior faculty. So NRRA opened doors for junior faculty and young researchers and engineers. So I really appreciate that. And again, my former engineer, I don't want to say student, is Dr. Choban. He's the one who, any detailed questions that you have, I think it may make sense that you go see him. This was his life for 4 years, Sinan, right? So he's the one who did all these tests and pulled this all together with me. So, and again, thanks to the TEP members and thanks to all my PIs. This was a big project, so I had a lot of co-PIs there. So, and Raul and John, first John was a technical liaison and then Raul take it. So thank is for that supporting the project. Yeah, sorry, last slide I talked too much. So any questions? Sorry, I think we're out of time. I have a bunch of slides for large stone subbase, but really don't have time to cover it. So yeah, go ahead. Any questions? Go ahead, John.
Sort of a surprise how creation changed. Cyber, I guess, is the purpose.
Yeah.
In any case, I guess my question is, it piqued my curiosity. What is your sense of the state of practice or the state of research for understanding action criteria and/or how that's done in the lab or how that's done in the field, given that concern for change in the gradation?
Yes, that was a struggle since we finished this project. It's something that we wanted to address. So we start addressing it. Sinan, feel free to chip in. I didn't have the graphs here, but we look into the degree of compaction impact on the hydraulic conductivity. I don't know if we did it for gradation, but that was something that we wanted to start in the lab first. We have the hydraulic conductivity data, but we didn't do the pre and after gradation. I don't remember, but that's something that needs to be done first. And then you compact it, you kind of have this energy application in the field, how it works. So instead of like Proctor hammer, that's why we say you use the gyratory compaction, because it is simulating the cylinder drums pressure better than the Proctor hammer that you put on the soil. So that's why we do gyratory compaction at different gyrations, and then look into the that would simulate the field condition, and then from there looking at the gradation changes, and from there suggest, hey, 200 gyration equals to this amount of compactor pass, so you don't compact anything further than that, so you don't have these huge gradation changes. But it's all speculation. I don't have the data at the moment, but that's the path that we would go with. Anything to add, Sinan? Yeah.
It seems like from this chart, from data material, the thickness increases with time significantly. My question is like, in the first presentation, when we talked about input material, you consider also that the time use or
The curing time or long performance time? No, we didn't. And the first presentation, we only focused on the lab work. And, you know, they were most of the time not even curing it. RCA people just put it in and run the test. They didn't even do any curing and all that. So we didn't consider in the first project. This was a unique project that thanks to, again, MnRoad, I don't know if anybody else has this opportunity to collect this data from birth to all the way to death, whenever those sections will be replaced. But thanks to Ben, he always asks us, hey, are you guys done with these test sites? And we always say, no, Ben, keep them as long as you can. So probably we will keep collecting more data. And this is really, I don't see any other people who have such opportunity. So these test cells giving really good information. Yeah. Any other questions? Right. Thank you all.
Okay, I think we'll get started here with the flexible team track. We have two more presentations that we're going to hear today on sustainability. And we heard one from Dr. Ishan Davy this morning, and we're going to hear from Dr. Amy Epps Martin now. So Dr. Amy Epps Martin has more than 27 years of experience teaching civil engineering materials courses and conducting research on safe, sustainable asphalt technologies at the Texas A&M University and Texas A&M Transportation Institute, where she is the AP and Florence Wiley Professor and a senior research engineer. She has 3 sons currently studying to become Aggie engineers. So please welcome Dr. Amy Epps.
Howdy. There you go. Good work. I know I can count on fans. That's the official greeting at Texas A&M University, where I've had the privilege of being my entire career. Last week, I spoke after my superstar student, Fan Yin, and today I get to speak before him. So it's good. It's all good. We're on the circuit together. I also want to thank the organizers for inviting me here today. I guess back to your wonderful state. It's beautiful here. It's nice. It's better than Texas right now for sure, and will remain so for the next few months. I was here in 2019, had the privilege of talking, and I'm glad to be here again. The title of my presentation is not exactly as advertised. I apologize for that. But I'm going to be talking about, or was asked to talk about, asphalt pavement sustainability efforts through NRRA, Capri, and BMD IWG, and NCHRP, and just kind of share some of my thoughts based on the projects that I've worked on or the efforts that I've been involved with. So a lot of acronyms. My husband always makes fun of all of our acronyms, but NRRA is kind of the kid or the teenager of this trio. Capri is like the toddler, and BMD IWG is like the baby. But there's a lot of cross overlap, and I think there's definitely opportunity. We should definitely have collaboration across these three groups, because there's a lot of things that I think that we can do together. So I want to just bring some of that forward today. I think a lot of people in this room are aware of why we're interested in sustainable asphalt pavements. They provide significant economical advantages and environmental benefits, even if we don't talk about those anymore. And but the key to getting those advantages and benefits is to maintain our engineering performance. And balanced mixed design is our tool, our set of tools that's going to allow a huge paradigm shift. Definitely in my career, and probably in everybody in this room that works in asphalt, it's just a big shift. And we got to get everybody on the same team, and we're working toward that with some of these efforts. So balanced mixed design is going to be the tool that allows us to get to those sustainable asphalt pavements and make sure that we're engineering each unique combination of modern materials, and make sure that we get the cracking resistance and durability when we increase our recycled asphalt materials, and make sure that we maintain our rutting resistance. So some of the strategies that we do to improve that cracking resistance sometimes can cause rutting issues. So we want to make sure that we don't do that. We want to get all those benefits. And there's the National Asphalt Pavement Association latest statistics, which are a few years old now. But it just makes you realize the magnitude of what we're talking about here. So again, I mentioned that BMD implementation working group. I'm going to go through each of these three groups. That's the baby in this situation. It's going to turn 1 this year. Then there's the Consortium for Asphalt Pavement Research and Implementation, or CAPRI. That's the toddler. It's going to turn 4 this year. And then NRRA, specifically the flexible team. I know NRRA is broader, but the flexible team is kind of the kid. And if you really reach back to the previous iterations, it's more like the young adult in the room. That was started, as my kids would say, last century. So all of this different ages, I guess, of these groups. Fan has a baby, so he's on the right hand side there, and I'm on the left hand side there. Just brings me to my three that you heard in the introduction. So it's birthday week in our family. We started with my mother-in-law, who's not pictured. She's 80 plus. That's the correct way to say that, I guess. On Easter, she turned 80 plus. My oldest, Jacob, on the right there, just turned 22 yesterday when I was traveling here. My babies, they're twins. They turned 19 on Thursday. And then my dad is also 80 plus, turns 80 plus again next Sunday. That's how his mom, who's going to turn 102 in June, refers to her age. So anyway, just wanted to mention that. Thanks. All three of my boys are studying to be Aggie engineers. The oldest one graduates in mechanical in a couple weeks. The other two are freshmen, and the oldest one's going to grad school, and they're all going to be sharing an apartment together, and makes me happy. They're at Texas A&M. We have lunch every Monday. Okay, if you give them food, boys will come to your office. So anyway, gosh. All right, so first let's start with NRRA Flexible. So I know we're all familiar with National Road Research Alliance. It's a pooled fund study. I love how there's always these numbers in parentheses, it seems like, for everything to do with the feds. So they're all like TPF-5, and then it just matters what the next number is. And MnDOT, of course, is I don't know what you call it, the lead state, I guess, in the pooled fund. There's different groups, as we know, that we've been hearing from at this conference, and the one I'm most familiar with and have participated in is the flexible team. I do like that it's called team. I think we should get jerseys. I want number 13. So NRRA Flexible Team includes 15 agencies, so a lot of different state DOTs represented and FHWA, and then very large group of associate organizations that include NAPA, NCAT, material suppliers, equipment manufacturers, SAPAs, and then there's quite a few universities involved as well. The goal of NRRA Flexible Team is to improve the future sustainability of roads through research. The goal of NRRA is to improve the future sustainability of roads through research and commitment to cooperative implementation. And then for obviously the flexible team, it's focused on new and rehabilitation of asphalt roadways. And so the key word here is sustainability. So you're going to see that throughout the three groups. The other key word there is implementation. Just some of the numbers in terms of the funding. There's different buy-in amounts for the agencies depending on the SPNR compared to Minnesota. So either 75,000 or 150,000 a year, and then each of those large group of associate members pays 2,000 a year. So there's about $1 million a year that go out to the research projects. 50 research projects were completed in the first iteration. 11 of them were in hot mix, and then 29 research projects started up with the second iteration, with 11 of them being hot mix. So about the same number. Generally, the projects are around 2 years and $150,000. Of course, this is heavily involved with the MnRoad test track sections. There's also monthly team meetings. There's seminars. The research pays off virtual seminars, and then the travel funds for the members to attend TRB and this meeting. In terms of the completed projects, again, I want to focus on the sustainability projects, but I don't want to not mention some of the other completed projects by the flexible team. There's some for construction and structural design on milling, smoothness, joints, and tack. Performance testing in BMD, there have been a number of them, which I think ties straight into sustainability, including adding rejuvenators, polymer modification for the newer cracking tests, loose mix aging for how to incorporate loose mix longer term aging for cracking tests in BMD, the reflective cracking challenge that with HMA overlays on rigid pavements that Ishan mentioned earlier. And then there's also been some cold recycling projects, cold recycling with rejuvenating asphalt emulsions, cold central plant recycling, and also a mixed rejuvenator synthesis and test sections. And finally, work on bitumen compatibility. So when we start throwing in these modern materials, how well does everybody play together in the sandbox? Some of the ongoing projects include recycling for perpetual pavements, field validation of warm mix at actual warm mix lower reduced temperatures for balanced mix design, analysis of Hamburg to get a moisture parameter, and then further work on the loose mix aging for cracking in BMD. You heard about the what do you call it? The Mercy project. You heard about that from Ishan. And so those are ongoing efforts. Some of the developing projects include the mixed rejuvenator test sections, the subsequent add-on. Oh, wait, was there? Yeah, sorry, the loose mix aging continues on the ongoing efforts. In terms of the developing projects, there's some developing projects on wet freeze perpetual pavement sections, reflective cracking sections on I-94, mixed rejuvenator test sections. So that's again sort of the third phase there. And then on recycled binder availability that Fan's going to be talking about. So I'm not going to go into it right now. Just how much of that recycled binder are we really getting? How do you quantify that? He's going to be talking about that next. Okay, next on to Capri. Capri is only a few years old, so definitely needs the experience of the NRRA group. In this case, it's also a pooled funds study with a slightly different number in parentheses through Alabama DOT as the lead state, and Auburn is sort of the organizing entity. In this case, there's 4 subcommittees that I'll talk about in just a second: critical issues, technology evaluation, technology transfer, and research roadmap. In this case, there's 32 agencies. So there's actually, I would say, more or about double the number of state DOTs or state highway agencies, plus FHWA. And then I would say there's about half of the associates, including 10 contractors, 8 industry associations, 5 materials suppliers or equipment manufacturers, and 3 universities. So sort of a little bit flip-flopped in terms of the number of members from the different groups. The mission here is with Capri is to improve asphalt pavement cost effectiveness, sustainability, keyword, and safety by addressing knowledge and research gaps in the industry, including developing research needs, providing technical guidance, facilitating small scale studies, and fostering implementation. So implementation, again, is a focus. The 4 subcommittees are shown here. The critical issues subcommittee identifies and prioritizes aspects of asphalt pavement performance and sustainability, and identifies gaps, hurdles, and unclear aspects in existing policies, procedures, and practices. So once those are identified, it sort of moves along to other subcommittees, but they're all sort of integrated. So this was set up sort of in a different way, if you will. The technology evaluation subcommittee identifies the technologies and processes intended to improve, again, back to the mission, asphalt pavement performance and sustainability. It identifies how ready is something for implementation and identifies barriers and recommends strategies to move it toward implementation. Technology transfer also recommends strategies to transfer technologies that are already ready into practice. Already ready, that sounds kind of funny. And then research roadmap is the fourth subcommittee. I'm involved in that one. In this case, we're kind of taking things that maybe aren't ready for implementation and figuring out what else do we need to do. So research roadmap assembles the recommendations for research and technology transfer needs from the other subcommittees and other entities, and prioritizes those needs and helps develop research needs statements and advocate for funding. So this just shows you a little bit about how BMD related topics would fit within those four subcommittees. So critical issues might identify that there's premature cracking on many pavements, especially those with high RAP contents. And it's difficult to evaluate those. Technology evaluation would say, well, what practical tests could we utilize during design or maybe during production? And how do we set criteria, performance criteria for those tests? Technology transfer might actually conduct training on those new BMD tests and hold workshops for revising specifications and quality assurance programs. And then research roadmap might say, well, we need to figure out how we can reduce the variability of those BMD tests, especially the cracking tests, and figure out ways that we can practically use these tests during quality assurance. So that kind of gives you a flavor for how they all fit together. In terms of the money, the agencies pay into the pooled fund $10,000 a year. The other stakeholders pay in $6,000 a year, and international members pay in $4,000 a year. So far, there have been about 5 research projects, although there's going to be some more starting soon. They can be shorter time frame, even half a year to 1.5 years, and about $10,000 to $226,000. They also meet twice a year, and they do include travel funds for the agencies to come to those meetings. And then there's also virtual webinars. This is our facility out at our, call it, somewhat remote campus from the Texas A&M main campus. It's where we have the Texas A&M headquarters building, which is the one you see in the foreground. And in the background is the Center for Infrastructure Renewal, which is our big state-of-the-art lab facility. And we just hosted the Capri spring meeting there last week. In terms of the completed projects that Capri has worked on, they did a look at a research database of the issues identified by that first subcommittee, the critical issues subcommittee. Also, there was guidelines developed for field validation of the test criteria for balanced mixed design performance tests. That came through the research roadmap subcommittee. And then there was a longitudinal joint best practices document created through the critical issues subcommittee. Ongoing efforts include looking at lag and dwell times, the times between when you sample loose mix and you make specimens, and then once you make the specimens to when you test them. So how does that affect, especially when we're moving into the world of BMD mixture performance tests? There's also a project that I'm working on with long-term cracking performance of high RAM mixtures. So we're going back to the 5 field sections from NCHRP 9-58. That have been around for 7 to 10 years, and we're going back and looking at that performance. So just that opportunity. So sort of like what you have at MnRRA, take advantage and get data and take the opportunity. So that's being funded through the research roadmap subcommittee. All right, and then the baby. The baby is the Balanced Mixed Design Implementation Working Group that was started last year. And in this case, NAPA and FHWA are the organizers, I guess, if you will. And in this case, there was a brainstorming session where there was 50 different ideas that the members, first of all, there's an application process for the members, and some members, a balanced set of members, I know, balanced set of members was selected, and they're going to rotate. So it's a small group by design. So it has only 7 agencies, including a city and a county and FHWA. And then the other members include 5 contractors, 2 industry associations plus NAPA, 1 materials, 1 equipment manufacturer, and 6 universities. So the members took the 50 brainstorming ideas and ranked them. What's the most important thing? What can we tackle first? And from that, we formed 6 different groups, and you'll see that's on the left. BMD framework, mixed design guidance, RAP integration, aging protocols, sample preparation, and quality assurance. Then when we met in person with ideas of what products that we could come up with from those 6 groups, we narrowed it down to 3 groups, 3 task groups, one called Aging Matters, one called Mixed Design Guidance, and one called Reimagining BMD. The overall objective of this group is to facilitate exchange of knowledge and experience and best practices and address technical and managerial challenges associated with BMD implementation, again, keyword, to accelerate adoption in a comprehensive and thoughtful manner. So there are also, like I said, in-person and virtual meetings. I think we're trying to meet once a year in person, once a year virtually, I think, again, with travel funding available for agencies and university personnel. And the products that have come out so far include an Aging Matters 2-page tech transfer document. Why does aging matter? Fan was involved in that. The Mixed Design Guidance, which I'm going to show a little bit more on. It's an infographic web page and a PDF document. And then Reimagining BMD is, there's 2 parts to that. There's a white paper that says why do we want to reimagine BMD from approach A, B, C, D to now tier 1, 2, and 3. The idea is that it's a process. You don't just pick one level A, B, C, or D and stop, that it's a process that you go through. And they've also drafted an AASHTO standard practice by distress type, including rutting, multiple types of cracking, moisture, and surface properties like friction. So I believe there's a link to the BMD implementation working group on the NAPA BMD resource guide page. And some of these things are up there right now. There's a few things that need to be revised, but there's going to be a webinar on June 4th that's going to be talking about these products. Just moving on sort of more generally for sustainable asphalt pavements. Again, I'm focusing on hot mix, I realize, even though I mentioned some other cold recycling types of efforts. When we do these high RAM mixtures, and what I mean by that is could be RAP and or RAS, and with 0.3 to 0.5 recycled binder ratios. Whenever we do that, we're creating a cracking problem with our stiff, aged, brittle RAP. And so we got to, sometimes when it gets high enough, we got to do something about it. And so the things we can do about it are these strategies. And so there's ones that are aimed at changing the quantities of materials, and then there's some aimed at changing the quality of the materials. And sometimes it takes 2 things, and both are important. So in terms of the quantity, what we're talking about there is the recipe or the proportions. So obviously one thing we could do if we're having a cracking issue is, okay, crank down the RAM content. So for example, we have a RAP in a recent NCHRP project that had a high PG binder grade of 127, which was the highest that we've ever seen in our lab and the highest NCAT's ever seen in their lab. So you're probably not going to want to put that into a mix at 40%. Okay. It's just that's not the right use of that material. It's not saying you can't use it. It's just like, what's the smart way to use it? How should you engineer its use? So of course we can reduce that RAM content. We can also increase the effective binder content. And we know the BMD cracking tests are definitely sensitive to that. So we can increase the effective binder content by adjusting the aggregate gradation, making some more room in there. We can increase the additive dose. And there's I believe we need some standardized methods for that. And then the other thing we can do is we can decrease the amount of credit we think we're getting in terms of the RAP binder. How much recycled binder are we getting? And Fan's going to talk a little bit more about that. In terms of the materials, we can change the binder source. A lot of times we want to say using a softer binder, a softer base binder, if you will. It can be softer on the high, the low end, or both. Often it's both. We can use polymer modified asphalt, or we can just simply change the source of the binder. And so those are some of the things that are available. I'm sorry. That particular strategy is definitely something that's available to the contractor. We could also change the other materials like the aggregate and the wrap source, but that's not going to be easy. That's not easy for the contractor to do. Including an additive is another good option and probably needed when you get to the high RBR values. So including an additive like a recycling agent or a warm mix additive is something else we could do. And sometimes we have to do two things, like for that very aged wrap that I mentioned. The infographic looks something like this. This is just the framework. It just shows some of the most common strategies available to the contractor. It does not include that recycled binder availability because that would be something that would be implemented by the agency. But for each of these levers, it gives some kind of an indication of the impact on the engineering performance, the economic costs, and the environmental impact. So it gives you some sense of that. I'm not showing you all the results here, but there's, if it's a big positive impact, it would be green. If it's a big negative impact, it would be red, and then it would be somewhere in the middle if it's in that yellow range. It also gives some sense of the practicality. Again, this is just based on our group's expertise in terms of easy, moderate, and hard. So we got these three groups. They're all very good efforts. They're all organized slightly different. They're all have slightly different missions, and they're all going about things slightly differently. But I think it's really important that we understand what everybody else is doing so that we're not reinventing the wheel. So the NRRA has more of those associates and university members, and it's also part of a larger effort. Obviously, the flexible team is just one part of the larger effort. Capri has more state highway agencies, and it's sort of organized by the process. And the BMD IWG is smaller by design, tries to have a balance of different members, and it's organized by product. So I want to mention that now that we have those first 4 products from the 3 task groups, now we just reorganized ourselves, and we're now moving towards laboratory versus plant results for BMD tests, sample preparation or specimen fabrication guidelines, and methods to set the criteria for those BMD cracking tests. So now we're reorganizing according to the products and moving forward. A couple of those are being written up as problem statements to Capri. So there's sort of some cross collaboration going on there. You can see here that the circle in the middle just tells you that for the 3 groups, NCAT and NAPA, of course, and FHWA are in all 3 groups. There's also representation, in addition to Auburn, by 2 other universities, including mine, and a contractor across all 3 groups. So there is some collaboration there. I don't know if we need an official liaison. Maybe we do. That's something I would like to propose. And then the smaller circles around there, or ovals, are the overlap with 2 of the groups. So there's overlap of 8 state highway agencies in 2 of the groups and 2 in the other 2 groups. There's 1 university in 2 of the groups. There's Asphalt Institute in 2 of the groups, 1 material supplier in 2 of the groups, and 1 contractor in 2 of the groups. So there is some overlap, which I think is good. Another thing that I think is important is to continue to share with each other where we are on this BMD implementation, since BMD, again, is the tool that's going to get us to sustainable asphalt pavements. This is just a snapshot of where we are with TxDOT in Texas for BMD implementation. This is based on the FHWA 8 tasks and subtasks, and it just gives some colors in terms of, everybody's going to be doing things differently, doing different tasks at the same time. But I think multiple groups are using this, including NRRA. So just to keep track and share with each other. In terms of the national research landscape, if you will, NCHRP 965 just was completed last year, and that was on durability of these high RAM mixtures, following on from NCHRP 9-58, which was focused on high RAM mixtures and using recycling agents. From that, there is a draft AASHTO provisional standard that's going to be coming out that kind of gathers all the tools for mixture evaluation, binder evaluation, some information on recycled binder availability, some information on recycling agent dose. So that's something to look forward to. Ongoing is NCHRP 9-68 that Fan will talk about just briefly. 9-70 and 9-71 and 9-72 are just now starting. Those are focused still on BMD. I mean, it sounds like a broken record, but it's such a big effort and such a big shift that I think there's still a lot of things to be done. And these 3 groups that I'm talking about here today are trying to take little parts and make sure that everybody's on the same page. And I think it's really, really valuable. So 970 is looking at how to incorporate aging in balanced mix design and acceptance. 971 is looking at the framework of how do you use practical tests? Again, sort of focused on what do we do during production. 972 is going to be on BMD test sensitivity, and 973 has not been started yet, but it's going to be on storage of specimens for BMD. So in terms of the next steps and future concerns, I do believe that engineered high rim mixtures is how we get sustainable asphalt pavements. And I know we're not supposed to say it, but that's the main thing that we can do with flexible pavements for low carbon transportation materials. We need a flexible framework because every agency is going to want to do things their way, which is fine, based on their benchmarking data, based on their former practices. So we do need a flexible framework. We need to make sure that we're looking at the broad range of materials and climates and all the people involved, right? All the agencies, all the contractors, all the material suppliers. We all gotta be on the same page. I mentioned the Capri project is looking at the thresholds that are in that draft AASHTO standard provisional standard practice, going back to the 958 sections. We also are completing a University Transportation Center project that's trying to give some guidelines on that infographic framework I showed you. Like, when do you need to consider recycling agent? When do you need to consider softer binder? When is the best time to use these different strategies? And then, of course, you also heard today from Ishan, we have to get some longer term performance, which is where some of these important efforts, especially with MnROAD and NCAT test track, come into play in order to be able to do the LCCA and LCA to capture these benefits. I also think we really have to have standardized procedures, protocols, and terminology. I'm all about consistency and also to minimize variability. I think as we shift to BMD in terms of mixture performance, then the question comes up, well, what do we do about the binder characterization that we've, that's working pretty good. So how does that fit in? So I'm not sure what the answer is there. Maybe it's still useful as a screening tool. And then we also have to be concerned about recycling. So that PG high of 127 is a sort of a glimpse to the future, I think, of recycling. So the more times that we do this, we're going to continue to get even stiffer materials. So maybe we just got to be ready with our strategies to restore cracking resistance, but also safeguards to maintain rutting resistance. I don't know. One idea is to have a liaison across these three groups. I also think it would be good to have a well-crafted survey. I know everyone doesn't like surveys, but something to help us understand what are the needs of the agencies and what are the concerns of the industry. And then I think we should still keep focusing on products. Like, it should be product-based. What are we getting out of this? What's practical, and what can we do in the short term? Not that we shouldn't be looking long term, but what can we do right now to move things forward? Because we're jumping in the pool. We're sort of done talking about it, and we're jumping in the pool. And so making sure that we have the tools to do that. I also want to acknowledge Ben and Randy and Richard, who gave me a lot of the information that I tried to pull together in this presentation. And also, this is just my thoughts based on what I've been working on with many others across the research world and the real world. So thank you very much. I went over by 1 minute, sorry.
Oh, that's good. Excellent presentation. Any questions for?
Anybody have comment? They're not that interested. Go ahead. Thank you.
Next presentation is from Dr. Van Yen. Dr. Van Yen is an assistant director at NCAT, National Center for Asphalt Technology at Auburn University. His research focuses on the balanced mix design, sustainable pavement materials, and advanced asphalt material characterization. He's a 3-month-old who we can't wait to teach about asphalt. His presentation titled Recycled Binder Availability.
Okay, all right.
Please welcome Van.
All right. Technology, right? It's great when it works. So, well, thanks very much, Curt, for the nice introduction. Good afternoon, everyone. It's a great pleasure to be here. It's as Amy said, it's I graduated from Texas A&M, had a great time working with Dr. S. Martin and amazing people in College Station. And last week, we were, in the same, meeting and in the same section. I presented first, and she went after me. And then today it was just kind of like, we come back here to again. So it's always a blessing to have the opportunity to, in the same session with my former advisor. I do want to acknowledge and appreciate NRRA for the invitation for me to come over here to talk about, recycle binder availability. For those of you who don't know me, I'm with NCAT. I've been working at NCAT for a little bit over 9 years. Have been working on balanced mix design, recycled materials. So it has been a great experience learning from the folks there. So one thing you guys probably have recognized, went to Texas A&M and now work at Auburn University, right? So you got 2 SEC schools. So in most part, it worked out really well, but only when those 2 schools play each other. And then that Friday before the game day, I got no email reply from my colleagues because they are diehard Auburn fans. And then not until I tell them War Eagle, and they're not going to reply to me or not talk to me. So it has been lots of fun working at NCAT, and yeah. So all right. So I guess what I'm gonna kind of like talk in my presentation is to kind of like follow on what Amy mentioned earlier regarding like sustainability, but dive a little bit deeper into one specific topic that is called recycle binder availability. Amy mentioned earlier that our community is a big fan of acronym. So here's another one, RBA, recycled binder availability. Okay, so why that topic matters. If you kind of like, hopefully by the end of the presentation, you guys, will, see some of the work that has been done in the past, some of the implementation effort that has been, taken on by some of the DOTs. Overall, the feedback is very positive. They do feel like a recycle binder availability is one of the strategies that can be used to advance, high RAP or RAS asphalt mixtures. So when I say like advance, I'm not just talking about increase the amount, but at the same time, make sure the performance is still there, right? So, at the end of the day, we still want the pavement to perform to last long. So I think that's kind of like really the end goal of that. I mean, for background information, many of you are very familiar with why, this topic matters. So I really don't think I need to spend too much time on the background. But I think, overall, using recycled material like RAP and RAS have significant benefits, on the cost side and also on the environmental side. But at the same time, there's challenges, right? If we just put more recycled materials into the asphalt mixture, in many cases, we're going to run into cracking issues. And, it goes without saying much that, cracking is, the primary mode of distress that we are battling against in our asphalt pavements. So if you look at, the cracking performance, I think Amy also touched on that earlier in her presentation. I like to kind of like think about the cracking issue from like 2 angles. One is on the binder quality side. The other one is on the binder quantity side. So on the binder quality side, we know those asphalt binders in RAP and RAS are more heavily aged than the virgin material, right? So they're, stiffer, more brittle, do not have good relaxation properties as a new material. And therefore, they are more susceptible to cracking and durability challenges. So that's one thing. On the other side, if you look at on the quantity perspective, so even though you have the asphalt binder on those recycled material that you can put in the mixture, but the reality is that not all of those binders can be activated to provide aggregate coating, aggregate binding, and also contribute to mixture flexibility. So many of us know that, in our asphalt world, we do like a super pave of volumetric mix design. So whether or not the binder in RAP or RAS can be activated or not, it's going to take volume, right? So in that case, like it's there, but it may not contribute to the way that we want the material to do it. So if you think about these 2 together, we got heavily aged material in the mixture, and also some of those mixtures may not behave like asphalt binder. And if you put these all together, I think it's not hard, to think about, why we are facing like lots of durability and cracking challenges. As Amy said, like over the last decade, there's a significant amount of work that has been done, from the research perspective and also from the implementation side to look into like a strategies that can be used to mitigate those cracking and durability challenge. Goes back to those two different angles. On the binder quality side, some of the agencies have very good experience using like a softer binder or recycling agent, right? Those are the strategies that work really well, that you try to improve the overall quality of the binder in the mixture, right? I mentioned earlier that the recycled material is fairly stiff, brittle. So now can we do something on the virgin material so that we can offset that stiffening impact from those recycled materials? On the binder quantity side, obviously, like in order to address quantity or the volume of the binder, the easy way to do it is just, hey, let's just put more asphalt binder into the mix, right? And there's different ways that we can do it using the volumetric system. If you look at where we are, kind of like across the country, several agencies have used like, try to increase the VMA or try to reduce or regress air voids, to make sure like there's more asphalt binder in the mix. So even though when we talk about the volumetric mix design, we look at air void, we look at VMA, but in my opinion, the most important parameter is VBE, right? The volume of the effective binder. And that is really the difference between VMA and air void. So if I keep my air void the same, I increase VMA, my VBE going to go up. Or you go the other way, you keep your VMA requirement the same, but you drop your air void, still you're going to get higher VBE. So that's just kind of like, the concept behind those strategies. One thing I will argue here is that if you look at this increase VMA or regress air void, I mean, those strategies are not specific to recycled materials, right? I can apply the same strategy to like a virgin materials without any wrap or rest and still work. But what about those recycled materials, right? That's kind of like the focus of today's discussion. For recycled materials, what can we do to address the binder quantity? So this is where like the concept of RBA plays a role. So that's where I'm going to share a little bit more information on how this system works and where we are and some of the ongoing work on recycled binder availability. So first thing first is what is RBA, right? Before we got into some of the detailed discussion, we want to make sure like, we're on the same page about, terminology. One thing I learned from Dr. S. Martin when I was at A&M is consistency. I think one time, one of her students told her, like, she told the students in a meeting saying, I don't care what you do, but you got to do it consistently. But I promise that was not me. But anyway, if you look at, what I'm showing here, this is a definition that we have been using at NCAT on ongoing NCHRP project. It actually came out from a study that Amy and her team did a few years ago for TxDOT. So it says like the amount of recycled asphalt binder from wrap and rest that activates and contribute to the total effective binder content in asphalt mixture. So basically, kind of like it goes back to what I said earlier on the previous slide, is that you do have those asphalt binder on those material in the mixture, but now you want to find out how much of that binder is available, is active. Is that going to be like 100% or is that going to be 50%, right? So that's really what we are going after for RBA concept. RBA is often expressed as a percentage, ranging from like a 0 to 100%. So it's almost like give you two like extremes. When I talk about 0% RBA, that means like all the asphalt binder in wrap and rest cannot be activated. And therefore, those recycled material more behave like a black rock. Okay, I mean, that just gave us to the kind of like the most extreme situation. Okay, we know that's not the case, but that's just a one extreme. On the other side, if we kind of like remain like a very optimistic, saying like, hey, asphalt binder is asphalt binder, right? We got asphalt binder on those material, therefore it's going to behave like the way that virgin material do. In that case, you would say like, hey, we can't get the full binder activation from those recycled materials. And therefore, in those situations, you get 100% RBA. So basically, it doesn't matter. It is a recycled binder from the wrap or rest. It's going to behave the same way as virgin material. And we know that is also not the case. So the reality is somewhere in the middle, right? We know it's not 0%. We know it's not 100%. But then the multi-million-dollar question is, what is that magic number, right? I think the answer to that question is just like the answer to many engineering questions. It's like, it depends, right? And it depends on different things. We believe when we talk about the recycled binder availability, it is a property of the mixture. Even though it is related, highly related to the recycled material itself, but we do believe it is a mixture property rather than just a wrap or the RAS property. Because, obviously we know like the property of the wrap and RAS matter. The stiffer or the more brittle the material is, most likely you're going to have a lower binder availability. Just from kind of like a basic thermodynamic perspective, you're going to take more energy to mobilize those binder on those materials. But that's really not the end of the story. I think in addition to the quality of the wrap and RAS, there could be some other factors that are related to the mixture side that can affect your RBA. For example, I put here mix design variables. When I started using like a softer binder, or I started using like a rejuvenator or recycling agent, it could affect by how much binder got activated, right? Because like the viscosity and the solubility of those material compared to those recycled material could play a role here. In addition to that, production conditions may also matter, right? If I increase my production temperature, obviously that's not going to be kind of like, an environmentally friendly approach. But, just from the, thermodynamic perspective, it have a higher chance to activate those asphalt binder in recycled material. So that's why, like, with that being said, we don't believe, RBA is just a property of the recycled material, but rather it is a property of the mixture. So I think that goes back to why I said earlier, like, what is that magic number? It depends. Because if you change those variables here, your number could change. So there's not a single number that's going to fit all the situations. If you look at where we are, this is a map based on information that we collected from NCAT, from TTI, and also last week when I presented at Capri, Mark Buncher from Asphalt Institute, he shared with me some additional information that they collected. And so I combined everything together and into this map. So this basically shows where we are on the implementation of RBA. So obviously the map is color coded. If you look at, the yellow color, that's Louisiana by itself. They don't use RAS, but when they use RAP, they do require adjusting the RBA, okay? And then in addition to that, there are 5 states. They are highlighted in the orange color. Those are the states that require RBA for both RAP and RAS, okay? And then finally, we have 3 states, Illinois, Ohio, and Tennessee. They also use RAP, but they don't require RBA for RAP. But for recycled asphalt shingle, they do require like a discounting that binder availability in those materials. I think the thought process is that RAS is much more like a stiffer and much more brittle than RAP. And that's why like they are doing that way. So now if you look at kind of like what kind of numbers are they using? I said earlier, there's no magic number, but if you look at what those states are doing regarding RBA, those RBA numbers range somewhere between like 60% to 90%. So if I just take 60% as example, what that really means is that they are assuming 60% of the asphalt binder in those recycled materials are active, while the other 40% is not. So this is gonna kind of like change the way you design asphalt mixtures, because when you do volumetric analysis, no matter the binder got activated or not activated, it's gonna be part of your volume calculation. But that's gonna change with RBA. And the other interesting part that we recognize by looking at what the states are doing is that the majority of the states that require a higher RBA for RAP as compared to RAS. So I think that's also really not surprising. Kind of like goes back to what I said earlier that, RAS is much more stiffer, much more brittle. So it's, even though it's part of the recycled material, but, RAP and RAS are 2 different animals. And I think, everyone in the room would agree on that part. So the question you may be wondering when I show you the number, it's like, hey, how do we determine that number? 60, 80, whatever you want to call it. So as part of the NCHRP work that NCAT and TTI are working on, and we did a very comprehensive literature review, look at what has been done on this topic in the US and outside the US. And we kind of like organize them or group them into like, a list here. So the first reaction you may have is like, hey, that's a pretty long list, right? Several years ago, I think we, still remember TRB or WAPT when everyone is talking about the different cracking tests. And then what we said was like, we got too many options. And then unfortunately, it's the same thing here. It's like too many choices, as they do not always give the same result. So what that means is like, if I pick a method here and another method down the list, and I apply the test methodology to the same material, I could get different answers. And there's a reason on that because like, the principle of those different methods are very different and therefore they are measuring different things. Some are more focused on kind of like the degree of blending between the recycled materials and the virgin material. Some are more focused on kind of like the mobilization of those materials. So it's really like, talking, apples to oranges. And that's why like we're getting different answers. Even though they are different, but if you look at the most common kind of like a principle that used in those existing work, this is kind of like, my way to simplify how the methodology works. So what they did is try to create like 3 different scenarios as part of the lab testing. So I mentioned earlier that when we talk about RBA, you have 2 extremes, right? 0% and 100%. So that's exactly what they did in their lab work, try to create or simulate those conditions. When you do the 0% RBA, in many cases, what they do is just to use ignition to burn the asphalt binder off, and then use the post-ignition aggregate to replace your recycled material in the mixture. It's not 100% accurate, but it's kind of like conceptually it does a pretty good job simulating the black rock situation. If you go to the other extreme, 100% RBA, how can we make sure we got a full activation of the binder in the recycled materials? I guess the answer is solvent extraction. So you use solvent to manually extract the binder and recover the binder out, and then you reblend those material into the virgin binder, and then add that into the mixture. So this is kind of like how that can be simulated in the lab. And then the last one is what people call like extra blending. So that's a real world situation. Whatever, the normal mixing procedure we do in the lab, that's how we do it. And then once you can simulate the 3 conditions, and then this is where like you can do your testing. Either you look at the binder testing, mixture testing, some are more index-based, some are more fundamental. But then like once you have those results, and then you can look into the relative difference in the test result, and tie back to those 3 different conditions and try to figure out what that RBA number is. So like I said, they're very different, but this is kind of like the most common principle, if you will, how the existing work has been done on this topic. For the same literature review effort that I mentioned, we kind of like summarize all the numbers that have been reported. So if you look at the RAP, based on the US research, the RAP binder availability can vary from 25% to 98%. That's a really big number, right? So it's almost like, I say I give you 2 extremes, 0%, 100%, you just close your eye and pick a number and it's already there. So I think it goes back to what I said earlier. It's like there are so many different methodologies and they do not always give the same result. And plus, these mixtures or these studies do not use the same material. Some use a material from, let's say, like Minnesota, Wisconsin. Some use from Alabama or Georgia, right? Amy mentioned like, one of the RAP that we tested in NCHRP 965 on the high temperature PG, it was a 127. Assume like, you guys don't have that RAP, in this part of the country, but that's what we have in the Southeast part, and that's very challenging to work with. So it's different material, different methodology, and I think those are the reasons why I contribute to the wide range of the RBA numbers. If you look at the RAS, it's somewhere between 36 to 63%. Some of you may wonder, said, hey, didn't you just said like earlier that, RAP should have a higher number than RAS, but now why is showing the other way? I think the reason is that, if you look at what has been done in the past, there are significantly more research on RAP than RAS. So they are not really, apple to apple comparison. It's just kind of like based on what has been published, what has been reported, those are the numbers. But, the bottom line is that there's a pretty wide range out there, right? And I think it goes back to what we said earlier. The answer is it depends because, the material, the mixture conditions, and the production conditions. So for the next two slides, I want to spend a little bit of time talk about how to incorporate RBA into mix design. So let's say like we agree on a number. Let's say like a 60% is that magic number that worked for a given condition. Let's say like in Minnesota or Wisconsin. And then now how can we use that number in mix design? So if we look at where we are across the country, there are two general approaches to handle that. The first approach is that you're going to discount the binder content or the GSB of the RAP and the RAS, so that when you do your VMA calculation, you're going to mathematically reduce your VMA, okay? And I just want to give an example to illustrate the concept here. Let's assume we have a 35% RAP mixture with 5.7% total AC, with the 3.8% coming from the virgin material, so the difference 1.9% coming from the RAP, okay? Let's assume like, the RAP itself have 5.4% binder content based on ignition or solvent extraction, whichever the DOT is using for your standard practice. And you do your VMA calculation and you got the 15.7%, okay? That just give you like, the VMA at 100% RBA. And now I'm saying like, hey, we know 100% is not realistic. I'm gonna apply a 25% discount factor on that binder content. So that's why you see like the number of the binder content dropped from 5.4 to 4.1. And then you do the same calculation. If you look at the number on the very right side, your VMA dropped from 15.7 to 15.3, okay? If I want to go a little bit more aggressively on that discount factor, saying like only 50% is available or is activated, then your VMA number dropped further to 14.9%. So now you see the kind of like how it works. All it does is to play with the volumetric system so that you can mathematically drop your VMA. And what it does is to eliminate that existing mixture with marginal VMA. In this case, if your VMA minimum requirement is 15%, then obviously like with 50% discount factor, that mix design is not considered passing. You have to go back to readjust. The other approach that is heavily used in the southeast part of the country, especially like Georgia and South Carolina, is they recognize the amount of binder that is not active. And then they add additional virgin binder to account for that. So if they say like, hey, there's a 0.3% recycle binder that is not available or not active, then they're going to require the contractor to put like the same amount of virgin binder into the mix, okay? The amount of virgin binder needed depends on like three factors. Obviously your RAP RAS content matters, and also the binder content of the recycled material matter. And then finally, your RBA number matter. So it's just kind of like a simple equation that is used to calculate how much additional binder is needed. Once again, give you an example. I say like a 20% RAP. The binder content of the RAP is 5%, and then that magic number is 80%. You put those three numbers in that equation, you got a 0.2%. So what we're saying is that the agency is going to require you to add 2 times more binder into that mix to account for 0.2% of the recycle binder that is not active. What if I increase the RAP content to 40% for the same RAP? In that case, you're going to double the amount of virgin binder, okay? If I lower my RBA number, saying like instead of assuming 80% available, I assume 60% available, and then the additional virgin binder further increase. So this is just kind of like the way, the DOTs over there, they are doing to address the recycled binder that is not available. Obviously we know with additional binder added into the mix, it's going to provide a better flexibility, durability, and cracking resistance, right? And also this approach is often known as the COAC, the corrected optimum asphalt content approach. So some of the benefits of the RBA, especially reported by Georgia DOT and South Carolina DOT, include like a better compaction, reduced segregation, more uniform surface texture, and significantly improved the cracking and the moisture resistance. So, overall, if you talk to the DOT and the contractor over there, I mean, they are on board. They have been very pleased with the performance of their mixes after they address RBA using this approach. And you may wonder, like, hey, what happened on the rutting side, right? I thought like, for asphalt pavement, we need the balance. So you got better on the cracking side, which is great. What about the rutting? In those two states, they don't have rutting issues, okay? They consistently get passing Hamburg and APA results. But the one thing that is interesting to mention is that both states use hydrated lime. It's just kind of like, the history of what they have been doing. And also they do not use softer binder or recycling agent, at least at this point, to address this. So I think this is important because there are different strategies that we can use to improve the cracking resistance of the mixture. But if we go beyond a certain point, we could create another imbalance issue and bring rutting back into the picture. And that's what we don't want. So it's important that, when we try to address cracking, we need to make sure our rutting resistance is still there, okay? Some of the work that we did at NCAT and also University of Georgia, based on lab testing data, including some of the index tests, fundamental tests, we consistently show that, wrapped mixtures with 60% RBA can perform even better than the virgin materials. So by using that 60% RBA approach. So I think that goes kind of like back to what I said earlier, it's just kind of like you recognize the amount of binder from the recycled material is not available and that you add additional virgin binder to address that. So this agrees really well with the field performance. So this is my last slide. Some of the remaining questions, obviously every time you got a researcher come here to talk, they will tell you we need more research, right? Some of the more work that we are doing, the NCHRP work, I mentioned like there's so many different tests out there, they do not give the same result. If this is the approach that we still want to consider as part of the BMD or as part of the higher RAM mix design strategy, we need standardized methodology so that everyone can do the same thing, like to talk apple to apple. The RAP relationship, the RBA relationship versus RAP and RAS source. We know like the stiffer, the more brittle the material is, most likely your RBA gonna drop. But is the binder stiffness the only factor here? Probably not. The other thing that has been recognized by the great work at NC State is the agglomeration of the particles, right? I mean, that could also affect your RBA. I mentioned RBA is a mixture property because it can vary depending on the mix design and production conditions. What we have found so far in the NCHRP work is that if you use softer binder recycling agent, that could help address your RBA because of lower viscosity and better solubility, that helps mobilize those materials. But there are still some factors that we have not found, the trend yet. Looking to the aggregate type, the production temperature, and the saddle storage. NRRA, I want to shout out to NRRA for starting a project to look into the long-term field performance of this topic. I know the RFP was released a couple months ago, and hopefully the research team will be announced sometime soon. But the idea of the project is to look into that long-term field performance. I think it goes back to what Ishan said earlier. We need the longer-term performance data to quantify their long-term performance and also use the data to look into the life cycle cost and the life cycle assessment, the benefit part if we are interested in those. And then on the implementation side, I know some of the states here, you guys use softer binder or recycling agent. If you are interested in trying RBA together with softer binder or recycling agent, I would recommend you verify your rutting resistance. So if there's a chance that if you pick your RBA number too low, you could like bring rutting back into your performance challenges, and that's not what we want. So always verify your rutting while focus on your cracking to maintain that balance. And then another big question that lots of DOTs will need to figure it out if going that direction moving forward is how to incorporate that into production. So once you start adding more binder into your mix, your production target and the tolerance may need to be adjusted, okay? So how to address that as part of your specification need to be, worked out. So with that, Curt mentioned I got, 3 months old at home, and so I have not had much sleep over the last 3 months, but those are some of the pictures I would like to share. So with that, thank you very much for your time and attention.
Great presentation. So, I mean, this is a topic I know, we've talked about it before, and I just recently presented on this also at EMI.
Yep.
So forgive me if I'm going to be a little opinionated, maybe I'll try and repeat.
That's right.
But I think you touched on a few important points that I wanted to highlight. I mean, one of them was the reach required.
Yep.
There's a reason why Georgia and South Carolina have been in Florida push these things with their wraps at PG 100, and in Minnesota and elsewhere, it hasn't been that difficult to get performance without changing the binder content, because your wraps are running at PG 80s. But one thing that I feel like sometimes gets lost in the conversation is if you're doing a balanced mix design, if you're actually determining your binder content with performance tests, there isn't any point of having any RBA calculations, because that's already embedded in those calculations. And I feel like sometimes the states that have pushed this, they push it as a way of being able to delay their PMD but end up making a more expensive, lower recycled mix essentially, where you kind of err on over asphalt. So I feel like states where already you have a PMD method in it, sometimes this is maybe there should be care when this is being pushed, because it pushes people backwards on implementation of PMD.
That's a great point. Regarding the first part of your comments, 100%. I think there's a reason for the state in the southeast part of the country tried to look into that. And I think one thing that our industry have not done a good job is to better understand the difference between wrap, right? I think there's lots of people out there saying wrap is wrap, but we know that's not the case. With the PG 120 something versus the PG 80 that you guys have in this part of the country, there are different animals to deal with. So 100%. The second part is the relationship between RBA and balance mix design. I'll tell you my opinion on that. For states that are gonna do like a true balance mix design, saying like, hey, I really don't care much about the volumetric because like there's just loopholes on that. Then in that case, RBA does not matter. If we need to add more binder, if we need to add recycling agent to meet the performance requirement, just do that. You don't need to know whether or not the RBA is 65.2% or whatever, right? But for states that are still trying kind of like the implementation process, saying like, hey, we know which tests we do, but we don't know the numbers. So the implementation going to take some time. I think many of you know me, like I'm a big fan of BMD, right? I've been, talking about that for a long time. But at the same time, we recognize BMD can take some time. So I think, for states that are looking for kind of like short-term solutions to improve the high wrap RAS mixture performance, RBA can be an option. But whether or not this is going to be cost effective, it's really dependent on the contractor. I think that's really the beauty of BMD is that it provides a buffet table. There's different options on the table that you can take to meet your performance requirement, either using softer binder, recycling agent, or addressing RBA. They all most likely can give you the performance, but at the end of the day, I think contractors or our industry, they will look at the one that's going to be the lowest cost, right? So this really, I don't think we are here to tell you got to use RBA. I think all we're saying is like this is a potential approach that can give you performance if that makes sense from the economic perspective, if that makes sense.
or on the sustainability side. So like, 5-6 years ago, actually the example of in the Min Road section that was done, 25% wrap went to 45% wrap, and it was 5.1% AC on the 25%, and it was 5.1% AC on the 45%. Part of it was a recycling agent then, but the AC didn't change. But using the EPD calculation with Emerald Eco, there was about a 19% carbon footprint savings by doing that shift.
Yep.
But then, when we worked into that, all right, what would have happened if instead we had to use like the Georgia method, or we end up with 0.7% more AC on that, so we're making 5.8, and actually majority of that carbon footprint saving was disappeared because in a sense we came down, our recycling came back down again, and we only had 3% savings on carbon footprint. So I think as we're going towards, like, if we're using RAP as a sustainability tool, then that would be it's not just cost. I think we have to say, look at that sustainability.
Yeah, and I agree and disagree, because 100%, if you address this approach, adding more binder, your cost going to go up, your carbon emission going to go up. But that's more on kind of like on the EPD side. But I think one thing that we also need to consider is like the life cycle. We should not just stop at the gate. If the payment can last longer, I think there's still benefits. So that's why I said I disagree, because I think
we have one last session here today. This is the Intelligent Construction Technologies Team Sustainability Topics session, and I will be moderating the session. I have some good news and some bad news. The good news is you've upgraded one of the speakers from me to Amanda, so congratulations for that. Thank you. Thank you. The bad news is you're still going to hear from me tomorrow, as part of the other session we're doing in the morning. We'll do a little DPS then too, but I take it Amanda's going to have some DPS in her presentation too. Okay, good. All right, awesome. Okay, so Amanda's the only one I'm going to read the bio because her bio is not in the program. So according to the internet, Amanda has over 8 years of hands-on experience with intelligent compaction construction technologies. Prior to working for Transtec Group, she worked in Alaska, which is beautiful. I just went on a cruise there, for a heavy civil general contractor specializing in highway and airport construction. They were the first contractor in Alaska to use intelligent compaction, and Amanda understands how to successfully implement new technologies at a project level. She used intelligent compaction as a quality control tool to consistently achieve maximum density bonuses and is a valuable resource for agencies and contractors wanting to implement and benefit from intelligent construction technologies. And I can validate that that is true. So you guys are in for a treat here. The reason we switch stuff up just briefly is that we're a lot of times preaching to the choir in the intelligent construction technologies team, and it's really important for us to help people understand beyond our little circle the value of what we're doing with our intelligent construction technologies. And this is kind of the fundamental tool that allows these technologies to be useful. You know, each intelligent construction technology is only so intelligent. And as with any engineering measure, you kind of need to combine different technologies to get the full picture. And we figured this is a really good opportunity to have Amanda share where we're at with the Veta software, and that'll tee it up well for Rebecca, and then we'll end with our heavy hitter, Dr. Zegeye. So let's give Amanda a round of applause.
Right. Thank you. Thank you for the opportunity. So yeah, I just wanted to spend 25 minutes going over kind of the current Veta capabilities. So if you don't know what Veta is, you are in for a treat, because by the time you leave here, you will definitely be able to talk about Veta intelligently. Okay, so here's how it's going to go. I'm going to give a really quick 2-slide introduction on kind of the history of Veta, and then get into the benefits of it and capabilities. And really the best way to do that is by showing case studies using intelligent construction data. So that's really great too, because we're also going to talk about intelligent construction technologies while we learn about Veta. So what is Veta? Veta is a standard platform that facilitates intelligent construction technologies. So the ones that it currently supports are shown here. So we've got intelligent compaction. This is equipment that gets mounted to your compaction rollers for soils or for asphalt. And so it can give you location, mapping information, temperatures, stiffness if you're measuring soils, can give you all that information about your compactive efforts. Paver mounted thermal profiling, this goes on your asphalt paver. It's going to give you the temperature behind your screed. It's going to give you a whole profile of temperatures that you can use to determine thermal segregation. There's a whole AASHTO standard about how to do that. So that's one of them. And then, of course, we've got the dielectric profiling system, or the density profiling system. So this is going to be the technology that measures dielectric constants and correlates very, very closely to density. And I know I am speaking to a mixed congregation here. So if you are not an asphalt person, that's okay. The takeaway, or the big thing to know about asphalt, is that density is super important. So kind of think of density as like the ultimate quality assurance metric that we're looking at when we're constructing asphalt. So a little history of Veta. Where it came from was actually early 2000s. And there was a lot of work going down with intelligent compaction, and there was a need for a standard place to view the data. So a place you could pull in the data and look at it. So it's all geospatial data, but like just the mapping capability, being able to see it and filter it and analyze it, it was a need. And there's a lot of different equipment vendors. And so having one standard place where it didn't matter where the data came from, but you could look at it the same way, was really important. So it was originally funded by FHWA and MnDOT. And it supported all of the data coming from the intelligent compaction vendors. So since then, it's grown a little bit. And as some of these other technologies have come onto the market, it was sort of like, hey, that would actually be really cool if we could bring that into Veta too, because then we're able to kind of start putting all of the pieces of our puzzle together, right? So, I always kind of call Veta like the ultimate quality assurance tool, because you really can get all the information that is not readily available otherwise. And so I'm going to show case studies and try to prove that to you in just a few minutes. But currently it's funded by NRRA Pooled Fund. So it's free to users. So anybody in here can download and use Veta for free, but it's updated and enhanced by the Pooled Fund. Where it's going, pretty exciting stuff. The big thing coming is MDMS, and I'm not going to say too much about that because I don't want any spoilers for Rebecca's presentation coming up, but that is the Material Delivery Management System, which includes e-ticketing. So e-ticketing too, that applies to lots of people out in this room, soils, concrete, asphalt. So more on that later. And then it's also going web-based, which is really exciting. So that's hopefully going to give you the ability to use Veta, you know, out in the field, maybe a little bit easier, and make it, you know, these are really big data files we're dealing with, and just make it a little easier to use, faster. Okay, so let's get into some of the benefits. Again, really the benefit is it's one place that you can look at all this Veta, all of this data in Veta. And so there's a standard AASHTO file format that the vendors can all follow, and then all of that data can go into Veta. So it's really, really great for leveraging your intelligent construction data, which I'm going to show you in a few minutes. And it's just a really good tool for being able to take the data, filter it, and analyze it, which is really important and really difficult to do if you don't have a software program to do it. And I've got some examples specifically I'm going to show on filtering and why that's so important. And it really is just supporting a kind of a digital as-built product. So there's a whole bunch of AASHTO standards associated with intelligent construction technology. Veta incorporates all of them. So, you know, we've got one specifically for DPS, one for IC, one for PMTP. The file format standard is up here. And then we've also got the data lot standard. And this one is really important because it helps you section out your data in a meaningful way, kind of the same way that you would do with, you know, lots and sublots for your materials testing. Similar kind of concept doing that for your IC data. So again, many systems, one software is kind of Veta's slogan. So let's kind of get into some of these capabilities. And I started out with like a really powerful example. It's really easy to kind of take for granted all that we're able to get from this. And I'm going to walk you through it in a minute. But one thing I just want to point out is that without this technology, this information is very, very hard to get from a construction project. So I'm going to show you all of this information. It's going to be really neat, and it's going to seem very obviously useful. But just remember that if we're not using these technologies, like none of this is available to us. So if you look at the far right, that is our DPS data. So remember that's coming from our dielectric profiling system. This is giving us a correlation to density. And again, density is really, really important for asphalt. And green is going to be good density in this case. Red is going to be bad. So areas of red are kind of in that failing density category. This might be like contractors being penalized because it's just really not what we want. And so you can see that right off the bat, you've got that kind of bad area. So one benefit, of course, of DPS is just the ability to make a map like this. Normally, we would test density with like a spot test location, and you can see on that map, depending on where you're taking your spot test, like, you know, you could get good or bad in that kind of small area we're looking at. But having the DPS, we're able to identify, okay, we have a density problem. But what's next? You know, what happened? And so if we dig into our other construction technology, we can really do some troubleshooting. That is, again, like coming from a contractor background, like this was always like the dream, right? Like having these tools is really, really nice. So if we look at our IC data, which is in the middle, you can actually see we have a ton of roller passes right there. So that the legend shows that in purple, that's over 20 passes. So if anything, we are over-rolling the crap out of this asphalt. But we still have a density problem. So what's happening here? And we can go to our PMTP data. This is going to be the temperatures behind the screed. And sure enough, this is our problem here. We can see we had a paver stop, and the area in white there shows temperatures as low as 140 degrees Fahrenheit. Now, if you look at the surrounding temperatures, they're between 240 and 260. So we're a good 100 degrees cooler in that area. Now, if you don't know much about asphalt, density is very, very important, and you have to have the right temperatures to get density. So it doesn't matter how many times you're going to roll that area that's only 140 degrees, you're never going to get compaction there. And so this whole method of being able to immediately kind of like look at these maps and figure that out is kind of what we mean when we say leveraging the ICT information in Veta. So I'm going to go through a few more case studies here. This one's a really good one too. I do have to have a little disclaimer here. Like, there was some GPS issues with this DPS data set, which is why it looks a little bit spotty. So yes, that happened, but this still tells a really interesting story. So the DPS data on the right, again, we're looking at green is good, red is bad. And we can see kind of really low density everywhere. So this is really alarming. This is kind of a situation where we're saying, okay, we're getting low density kind of throughout. What's happening? And the contractor on this particular project originally was looking at the IC data. And again, it looked okay at first. But remember, temperature and roller pass data kind of go hand in hand. Like, you can't really look at one without the other. So they decided to apply a filter in Veta that removed all of the temperature data below 210 Fahrenheit. So that was kind of their threshold, is like, we want to be compacting everything above 210. So let's get rid of all the data that doesn't meet that. And what they found is only one pass met that criteria, and sometimes none of the passes met that criteria. So again, even though we're showing as high as 20 passes in some areas, when you consider temperature, the temperature wasn't there. And as a result, all of the density was very low. So the whole point of using this technology is to improve our paving practices, right? So the contractor was able to take this information, go to the paving crew and say, hey, you know, we're not paving hot enough. We need to bump up temperatures, slow down the paver, you know, whatever it is. They took a corrective action, and then they repeated this exercise and look at the density as a result, green all throughout. And they did the same filtering exercise where they were able to look at all of the pass data above 210 Fahrenheit. And you can see in this case, you know, 3 to 4 passes pretty consistently. And so this is kind of the whole point of what we're trying to do is let's identify areas that we can fix, and then let's make a corrective action and pave better, right? So again, it's not easy to do when we don't have this data. So this is sort of a map that shows, or a graphic that shows current capabilities and like future pretty soon coming in the pipeline, and then like maybe like dreams that we have for Veta. So everything in yellow is currently supported. So that's the stuff we've kind of talked about, the IC, the PMTP, and the DPS. Just adjacent to those yellow shapes are the material delivery management system, which Rebecca is going to tell us all about, and the interfacing with AASHTO projectware. So that is like on the horizon. We can see that coming. And then some other things that like wouldn't that be great to bring in? You know, if we could bring in pavement smoothness, GPR thickness, let's see what else we got here. 3D surface models, like just tons of different ideas of like really just building up this quality assurance tool that we have. So one of the big capabilities too that I just wanted to mention is the filtering. And I remember as a contractor, when I was first using this technology, my biggest concern was who is going to be filtering and analyzing this data, because you have to do it correctly or it doesn't mean what you think it means. And so I just want to show a quick example of maybe what the raw data would look like before and after you filter it. So what I'm showing here is PMTP and IC data. And when you're scanning with PMTP, you might be over scanning the fresh asphalt and collecting like cold edges of whatever's adjacent. And that's good because then you ensure you're scanning the full map, but you want to remove that before you do any sort of thermal segregation analysis. Otherwise, you're going to get severe thermal segregation everywhere, which is not correct, right? So you've got to remove that. You want to kind of filter this again into lots and data lots so it makes sense. Roller and equipment mobilization. Sometimes operators turn the technology on at the beginning of the day and they don't turn it off again until they're done. So if they leave to get water, if they mobilize to the site, sometimes you have that, you need to remove all that. So this could be something, before you filter it. And then in Veta, you can pretty quickly apply some filters and section it out into a meaningful way, and where you can quickly go and run your analysis and it's accurate and represents what's actually on the project. So super important. And again, it's really difficult to do something like this if you don't have a software program to do it. So the other great thing about Veta too is we've tried to make it really customizable for DOTs with different, acceptance criteria, different things they want to look at. There's a very customizable way of analyzing the data. One of the really useful metrics for IC data is pass count coverage. So this is where you know that you need a certain number of roller passes for your particular mix to get density, and then you can go and check what percentage of your project actually achieved that. So really important. Of course, you can bring in temperature specs to go along with it to make sure you're getting the right number of passes at the right temperatures. Really detailed sublot analyses. There's a lot on this page, but what's neat is you can section things out into sublots. Everything's customizable. You can set some thresholds where you can quickly see kind of pass or fail with whatever you're looking for. We have these temperature and time curves, which shows your roller temperatures and time between roller passes. That's a great quality control tool. Here's one for DPS. You can see all of the general statistics. Again, you can set any sort of criteria that you want. And then again, just really being able to leverage this information really efficiently too. You basically, to view something like this, once you import your data, you can kind of go and click through and immediately kind of find, okay, here's an area of low density, here's the issue. So, and again, in this case, it's a paver stop. When your asphalt is cooling to below 140, you're going to have density issues. Another really great tool that's fairly new into Veta is this heat loss tool. So all of the IC data is time stamped. So we're collecting temperatures on our equipment and everything is time stamped. So we're actually able to generate this heat loss curve. And if you're using both PMTP and IC data, it's going to pull all the temperature data. So time zero is going to be your temperature behind the screed of your paver. And then all of the other temperatures are going to come from the rollers. Now, when I was quality control manager, I was obsessed with temperatures. I would want to know what it was at the plant. I would want to know what it is at the truck. I want to know what it is dumped outside of the truck. I want to know what it is behind the screed. I want to know what it is at the roller. The whole thing is very, very important. And so this now is a tool where you don't have to run around with a temperature gun anymore. You have it all here. And so you can just kind of click anywhere on your map and it'll pull up this heat loss curve. And you can see, how far it is, how far your rollers are behind your paver. That is an incredibly useful thing to have. And I'm going to show you an example of that. Oh, I don't have it in here. Okay. So, you can see here only 2 minutes passed before my rollers hit my paver. That's great. That's exactly what you'd want to see. If you pulled up a graph like this and your rollers weren't hitting that map until, 12, 15 minutes later, you probably have a problem. Balancing your paving operation is so important. And I think it makes it into most DOT specifications that they need to have, the right number of trucks and the right number of rollers and the right paver speed. That's really difficult to enforce without a tool like this. And I see all the time, where the paving operation is not balanced. You can catch it right here with the rollers falling way too far behind the paver. So here's another great example. I always have to steal Curt's examples. Thank you, Curt. He's always got really good data examples. And so this is a really good example of just, if you're measuring measuring your density, measuring your path count information, your temperatures and everything, you really can just learn so much more about your projects. So here's a good example where, you can see we have kind of a density issue on the edges of our pavement. And this is something I see very, very, very commonly in all of the data that I look at. And it's because it can be really hard to get density on those unconfined edges when we're paving asphalt. And I remember when I was working in construction, a lot of times I would talk to my roller operators and they'd say, oh, well, the mix is sort of shoving at the edge, so we're just going to stay off of it. And that's really common, what we see all the time. And so, that's something that, we in this room have to decide, is that what we want? Or do we want to try to do better? But now we have that information here where we can kind of, have that information and make these decisions. But you can see in that's what happened here, is there's only one pass on that edge. And as a result, we've got really low density. And you can see, in the areas where we've got a little bit higher pass count data, you can see a little bit higher density, those areas of overlap. So it really all makes a lot of sense. But again, just keep in mind, if we were only pulling one spot test, depending on where that spot test was, we could have a very, very different number. And if we had a bad core, what do you do with that without this data? Well, what happened? Well, I don't know, like you don't have the troubleshooting tools at that point. So this data really just gives you the full picture of what's going on your projects. I think I got one more example here, kind of a very similar thing, but again, just how powerful this information can be. So we've got our PMTP at the top, that's going to be right behind the paver. We've got our AC data in the middle, and then DPS, and you can just kind of look again, paver stops, asphalt cooling, that's always going to give you some issues with density. Maybe we can't eliminate all paver stops, but, we want to do our best to minimize those because we know that that's going to hurt us in the long run. Number of passes, temperatures, all of it's really important. So this just is another example of, you can see, some density issues on the edges where there's only one pass, the cooling temperature from the PMTP, and then a lot of areas that look really good too. Okay, and that's what I had. If anyone has any questions, I don't know how we're doing on time.
Yeah, any questions? Let's thank her.
Okay, our next speaker does not need an introduction. And more importantly, she asked me not to introduce her. So here we go. Oh, wait.
Perfect.
Oh, okay.
You were the double dots over.
You might have to come up here, Ben. Let's see, hide presenter view.
Yep.
All right. That was quality assurance, just in case. Wait.
All right, perfect. All right, so I'm going to talk today, continue on from where Amanda was here with Veta, and go through the contract that we currently have with the Material Delivery Management System. And as Amanda said, it includes your e-ticketing, so that affects all of you in the room here for all material types, for aggregates, asphalt, and concrete. So with that, the whole enhancements that we've added to Veta, they are all meeting AASHTO MDM 1UL. So this is a new standard. It was published in November 2023. MnDOT, we are the steward of it. So if you ever have modifications or anything that you want added to it, do give us a call and let us know. We do have some modifications queued up here that we'll be submitting here soon. So, anytime if you have anything, just send it our way and we'll send that into the committee. So what is the Material Delivery Management System? It's exactly what the name is. It's just a system that manages data associated with delivery of material to a contract. So what does that mean? In this provision, we're right now looking at aggregate, asphalt paving, concrete paving, and your ready mixed concrete. So this provision is written so that the specification, the standard is written so that it can grow. So as you get more material types, the other things that we want to add, steel, anything else, we can add to it. We did intentionally set up the structure of the standard to allow for growth for more material types. So if you have another material type you want added to the standard, do let us know as well. The data that we currently have included in it is your source data. That's your e-ticket. So that's your bill of lading. It's all your mix information, your weights, ingredients, if you require those for whether it's bituminous or concrete. All that information's in there along with your truck ID, who's hauling it, that information. Table 11 in the standard is your hauler information. So this is more focused on your labor compliance information that often every state DOT needs to be watching for your labor compliance, and that includes your prevailing wage rates. With that, you need to know driver names, your truck ID. It also has broker names, the company that's hauling it. We did add permits. There was a lot of interest in overweight permits to be added in here too. So having that number in here. So if you want to calculate, especially for those asphalt tickets, if you want to calculate overweight quantities, you're able to do that along with that maximum gross weight that's allowable. And then the last table there is loading and delivery events. So this is, again, focused on labor compliance, that duration of time that it's in transit for paying those prevailing wage rates. But it's also for use if we're not going to have a person there collecting tickets, knowing that the material indeed made it to the project, right? We have triggers in there so that we know it made it to the job site, we know it got towards the paver, and we know that it dumped. So all that information gets automatically recorded for those states that do require it. So the AASHTO standard is written, so each state, you can pick and choose what you want to include. You might not want to include hauler data or loading and delivery event. Maybe you just want to focus on the e-ticket, that source data. So it does allow for that, but it also allows for growth into these other items. Earlier, we were talking about EPDs, and A4, A5 when you get into construction. So at that point, this loading and delivery event data becomes of interest, right? Because now you have that hauling duration to the project, right? From the source all the way to the job site and how long it was at the job site. And then its return visit back to the source. So there's a lot of information that can be captured there along with helping with the audits, whether it's internally too. You have that information and the flow rates that Amanda was talking about too for delivery of material. The AASHTO standard, we also, we had a committee, and I didn't include this slide, but basically there's close to 300 individuals across, different state DOTs, along with academia associations and so forth. And so we did elect to include in their standardized software that's agency specific. So the standard was written to include AASHTO project in there. It does work for those states that are non-AASHTO project users as well, but a lot of the terminology, if it's already been written and included in AASHTO, we are including it here. And we're hoping those of you that are AASHTO states that if a term hasn't been created in AASHTO yet, and it's been created in this standard, that you use that in AASHTO. So, and then along with Veta, and then all using open APIs to allow that data interoperability between all the different software platforms. So on the agency side, in the appendix of that standard, we do have your testing and contract administration. So this is basically everything your construction staff is doing out there that they typically write in diaries or on the paper ticket that we're now going to be taking care of in the Veta software. So again, we do not want to be typing this information into the contractor's platform, right? It is agency specific. So we are putting this into the Veta software along with agency verification. Again, we do have auditing. We want to make sure that we have good, valid data. And so we do have processes that are going to be included in here to allow for some automated verification, but then also some manual that can be recorded by the inspector to show that, yes, after X many tons or cubic yards, we did do a random verification on the material being brought to the project, that it indeed matches that ticket, right? That e-ticket. And then the last item here, this is not included in the AASHTO standard, but we do plan on bringing select data fields from your EPDs into Veta. So Veta is not going to be storing your EPDs, but there is select information that the inspectors are going to want to see out there with respect to that mix that was delivered, right? And attaching that to the e-ticket. So In the future, we will be adding those fields into the AASHTO standard and how we want it connected for the different e-tickets. So again, that data will be pushed to Veta. Veta will then connect it to your e-ticket, and then it'll be at the fingertips of your inspector out there. The data transfer itself, so any vendor, there's about 25 plus vendors out on the market right now that provide some sort of solution for the MDMS. And so with that, again, as Amanda was articulating, we need some sort of standardized platform. And so any vendor that they meet this AASHTO standard MDMM 1 UL, right, that data is compatible with Veta. So we'll be able to bring it into Veta as long as they meet that standard. And so with that, the way the flow is you have your typical loadout software, right, at your concrete plant or your asphalt plant. Traditionally, it would, print out your bill of lading, your paper tickets there. But the new process here, when we digitize things, is then through a solution from the vendor or through open APIs, that data will then push to a third-party system. It could be either made by the supplier or it could be a third-party vendor that the contractor elects to use or supplier. From there, then we'll have bi-directional data going back and forth to Veta. So we want all of that MDMS data that we were just talking about, that e-ticket, the loading and delivery event data, the hauler data, to be pushed to Veta so that we can look at it in a standardized format out in construction. So if you have concrete tickets come in and you have aggregate and you have asphalt and they're all using different vendors, this then allows you to look at it in a standardized platform under one contract umbrella. Veta is a software. Veta is an agency software that Amanda just went through. So originally, MnDOT, when you look through our flow, we originally funded creation of it, and then eventually created more features through all the different pooled funds, including NRRA. So it's an agency software similar to ProVal, for instance, for smoothness. So the contractor or supplier, they're going to purchase a software package, right, to be able to pull the tickets from the loadout software, or they'll write their own. So they'll either write their own or they're going to work with a third-party solution. And there's 25 different software platforms out there that they may use. And then that data then will push to Veta. And so Veta is considered the agency standardized platform. So regardless of the 25 plus vendors out on the market, our construction staff will be able to view it. So it all looks the same regardless of which vendor it comes from. Great question. And so with that data will then push to Veta, but we also want to push some of the data back to the contractors and suppliers. So if we reject a load, what the reasoning is, maybe there's weather that's happening and we want them to stop delivering mix, so we will have that bi-directional data going back and forth. And then also conventional methods, you can download a CSV file if you want, but in the future then too, is because we are establishing it through open APIs, those states that are AASHTO project users, we will have that bi-directional data flow with AASHTO project, and your non-AASHTO project states, it'll also work then with your databases that you have. So, and why bi-directional? Again, AASHTO doesn't want all the tickets, and probably most state agencies don't want every single ticket pushed to them in their systems, depending on what system it is and what they're using it for. And so it could be just summary data that's being pulled from there. And then later on, we're dumping all the data set for archiving purposes for the contract files later on. So the other data that we want from these systems would be like your pay items, or if we want to connect, sample IDs, for instance, or test results, being able to push that information to Veta is extremely helpful to tie to the other data sets. So as part of it, I'm just going to float into, there's a lot of DOTs that were wanting to know what features we're adding in here for the MDMS. And so these exist now. We do have a contract creation wizard. So you log into Veta. And I want to articulate, Amanda was talking about IC, thermal, and DPS. Those are all currently in the desktop Veta version. And again, that's being created to a web base. But the MDMS, that module, we created in a web-based platform right away. And so this is on the web, and so you'll be able to access it through traditional means, of logging in. In there, you'll follow this wizard, and you'll be able to create a new project. You'll be able to edit an existing one if you made a mistake or had additional information you need to add, or you can use an existing contract as a template for creating the next one. So it does allow us to create that top contract umbrella then for all this MDMS data to be spooled to. In there, we're all on construction, everything's related to pay items, right? And so with that, right now, it'll be an importable means of supplying that information to Veta, but eventually we will want that information pushed from Ash to our project or another system, but we do have the ability of adding it through an Excel sheet here. And so with that, you'll be able to add standardized material codes, because we do know there's creativity there sometimes on the contractor side, along with your pay items. And so the importance here is then now you can tie it to each of your e-tickets, right? And use that for payment purposes. And then also as your estimated quantities for testing and sampling. So you can start cleaning up the data to create those automatic tabulation queries. Geofences. So every state, you all have control sections on your projects for your construction projects. You have them chopped up, right, into smaller sections here that you're monitoring for costs and performance and so forth. But you also have funding categories, even if you have one funding category for the entire project or multiple, you know, and that's just your funding splits. Maybe it's 80% state, 20% federal, you know, whatever those funding splits are. In Veta, we do have the ability that we are creating these geofences then to be able to track those different funding categories and control sections. And so now you can tie your placement of your material to those for performance later on, but then also for payment purposes so that you can tabulate your quantities as needed for your contract, right, for payment purposes. So in Veta, we have the ability to create those geofences, which then allows us, if you know your dump location, we can auto trigger it to record it, or you can manually assign it to that. And so you can do these geofences by adding an alignment file and then using offsets and coordinates to draw those polygons, or offsets and stations, or you can hand draw it, you know, just by clicking it and stuff. So, and then you can name it accordingly. Also, you have different metadata associated with it. So again, that's putting your control section IDs, your sub-project IDs, your funding categories, counties for prevailing wage purposes. Every state either has their own regions for prevailing wage, or you have on the federal level, which is county based. And so this allows a quick way without having to look up latitude and longitude to see which county it was delivered in for prevailing wage purposes, and then along with a quick description here. For your Bentley states, I just want to let you know those states that use Bentley for your design. There is a project called QuantumMate, and it's part of the Bentley Infrastructure Cloud. And what QuantumMate is doing is it's grabbing from your design files. All your elements have metadata associated with it when you're using Open Roads Designer or Open Bridge. And in there, if your 3D models or even your 2D plan sets are created correctly, and you have each element in there with the funding categories, pay items, and you know, all that associated metadata. Currently with QuantumMate, that data will then push to Ash to our project or to other databases to be able to populate your estimated quantities by pay item, right? And so I just wanted to share that with you. And so we are talking to that group with QuantumMate because we want that information sent to Veta, so we're not having to redo it. And so I'm sure non-Bentley states, the you know, Autodesk and stuff will probably create something similar, but I'm not aware of their feature right now. But Bentley does use QuantumMate, and on the map here, you can see the states that are part of this work with QuantumMate. And the next step is connecting it to e-tickets. So if you're a state on here, do bring up Veta, remind them about that. We have been reaching out to them, the group, and I don't know who all your reps are for QuantumMate, but we do want to make sure that as we're connecting it to the e-tickets, that it's meeting this AASHTO standard here, that we can bring into Veta as well for a one-stop shop for all states. So. The other thing, we have workspaces in Veta as well. And so those are created per contract, contractor, and the vendor, that third-party system that's being used. And it's basically a glorified folder that all that MDMS data pushes to. So if you have a contractor here, called crisscross contracting. And they'll create a workspace here for each of the vendors that they're using, and it could contain multiple sources, multiple plants underneath there, and that data will spool in here. So what this allows us to do is to make sure that you have that data integrity, that no one can see the data that's from another contractor, and so forth. And it also allows us to do that relational tables where under this contract umbrella, we all know we have multiple sources and materials come into the project. We can then combine it all together, right? It's all databases in the background because we are in the agency software to have that relational views. So this is super handy. If you had, for instance, bituminous mix coming from multiple plants, we are then able to compile all that data together for the same pay item, right? Or for testing and so forth. So it's extremely powerful. You can't do this in a lot of third-party systems because they don't talk to their competitors, right? And so another positive here with Veta, being on the agency side, that we can control that and compile all the information together. Viewing of the tickets. So as you expect, we do have a ability to view all your e-tickets in there. You can double click on a given ticket if you want to just see it in a conventional way of a ticket that you would see on paper, but also in a table format, which is nice. And most of us like to run through the tables. Lots of data fields in there. So there's an ability to select which ones you want to display out in the field. You can select them all or just a few that you want to look at. You can download all the tickets, but also if you had some sort of system failure out there that for some reason the tickets weren't being pushed correctly and you need to hand enter things, you could batch load tickets into here as well on the agency side, not the contractor. Assigning those material codes and pay items that we were talking about earlier. So we do have that ability then that you can assign it per ticket or globally to multiple tickets. So that is super nice. So the first time it starts seeing a certain material code come in, you can then assign it so you don't have to keep doing that. Here's just showing in the e-ticket those standardized material codes and pay items in there. So now you have it all connected to the information so you can use that for tabulations. The loading and delivery event tables. So again, those states that elect to do asset tracking, you will have then the timestamp in the latitude and longitude of when that truck is entering and exiting the source, your plant. And then also you'll have that timestamp in latitude and longitude when it's entering and exiting the job site. And then when it gets to that mobile geofence around the paver, for instance, if we're talking about asphalt paving, it'll automatically record the dump location along that latitude and longitude along with the date and time stamp. So extremely powerful information. And this ricochets back to what Amanda was talking about too with that asphalt delivery, for instance, knowing those flow rates, which affects your paver speeds, right? You can slow down instead of stopping, knowing that, it's going to be X many minutes before my next truck arrives. So, and again, just knowing if there's anomalies in your flow rates, well, did that truck really show up? And so you can start digging down into the data and see what's going on. Or they were out on the job site and they split the load, and that's why we have cold mix and so forth. So. In here, we will have dashboards then to help the inspectors out there. They want to know how many trucks are in transit, if you have bad weather or just to know what's expected. And then also those quantities, so in here, we'll have a summary of how many trucks are at the source, how many are in transit to the contract, at the job site, in transit back from the job site to the source, and then how much quantity that's been scaled in transit and dumped. So just kind of at the fingertips, we're making different dashboards here to help construction. Here's just an example. This is a future feature that we're going to be adding here is we do want to be able to auto record those dump locations with respect to the other intelligent construction technologies, or if this isn't associated with other technologies, you're not using them, we still want to be able to record the dump locations so that we know where the material is placed. And then you can double click it, you can see the ticket, and then you can tie it to your lab testing. If you have failing tests in the lab or in the field, you can know, okay, it affects these trucks and what your remove and replace limits are if you have some workmanship issues or anything else out there. Here's just kind of an example too. We would, if you had the technologies, again, we're going to intertwine all the different data sets together. Sampling and testing, we do have another wizard here for sampling and testing and contract administration. So in there, you'll be able to select whether it's a test or a sample, and whether that's the test or sample is done at the source or at the dump location at the job site. And in there, you'll be able to put the test ID, and then there's a drop-down list that is state-specific that you can add in there of the different testing types, and then along with the test value if you'd like to use this wizard here for entry of that information. And same goes with sampling. There's a drop-down list there as well for sampling that is state-specific. Right now, by default, we're using what's an ASH2WARE project for these drop-down lists for both testing and sampling, but you can, modify it to be state-specific for you. As part of that wizard, we also have contract administration. So part of the contract administration is we do want to tie it to that project category geofence out there, right? Those funding categories and control sections. So it allows you to do that manually, or if you are recording those dump locations, it will be connected to that as well to auto-populate. And then if you have to tweak it, you can manually if needed. Also, we have different events. So when inspectors out there, some states are requiring that they still record the full load was placed for every truck. So we do have that event in here for those states that have to manually record that. But we also have the option that it was not placed. We have seen that where trucks drive through and they don't dump the load. So then we can, select not placed. Rejected, if you had a rejected load, you can put it was rejected and what that quantity is. Partial load delivered, you notice, hey, it's not a full load here. They must have stopped somewhere on the way. And you can put that it was a partial load and they only delivered X quantity. Never arrived, wasted, and then paid for as for those cases where you need to pay, swap out your pay item for a different use than what it was originally planned for. So here, we also have splitting loads. So if you end up splitting the loads out there, the inspector will be able to assign that along with the different quantities for the different splits. So we have it out to 4 splits. I haven't heard of a state doing more than that. I think Florida was the winner here with 4 splits, but if we need more, it's an easy table that we can add to. And then the data entry, like we said, you can put the quantity in then for those different events, any notes, and the location information, whether you're just using station offset, latitude, longitude, any of that information could be included in here. And then from there, you'll have a summary table that has all your sample testing and contract administration information in there. So it'll be easy for the inspector to see that. Those that are ASH2WARE project users, the tickets along with this information, will be able to be imported into ASH2WARE project as well, or non-ASH2WARE project states for your database system. So Amanda went through some other examples. We're just going to show you one example here of, just integrating the different, just for an asphalt example here of MDMS data to thermal profiling. So we had a project here that you can see some cooler paving temperatures. So this was collected with the thermal profile system. So that blue area, the temperatures there, you can see around, anywhere from 190 to 210 in that area. And then around there, before and after, it was a lot warmer. And drilling down into the data in Veta, you can right click and see all the metadata associated with each pixel of data of those gridded spots. And so from that, what we cared about was the timestamp. We wanted to know what time was that placed. So there was some discussion over this cold material that was out there. So it was at 7:52. And so then, because we had that loading and delivery event data, we knew what time each of those e-tickets were and where they were placed. And so we were able to tie it to the ticket number along with the truck ID. So then we drilled down further into the data and we found, this truck was actually at the job site for 42 minutes. So what was going on that he didn't dump right away? And so then drilling down even more, and this is hard to see in the room, but basically on here, you can see six loads. It's from the bottom up is the order that it was loaded at the source, but it actually dumped last. And it was the third one loaded in this sequence of trucks that you can see on the screen. And so looking at the information even more, because we do have the breadcrumb trail, you could see that the truck actually split its load. The first part was paving the shoulder. It was dumped on the shoulder, and then it went to the mainline paver. So hence it was so much cooler by the time it was 42 minutes later, right? By the time it dumped. So again, extremely powerful information that's now at the fingertips for helping to investigate what's going on out there. So Amanda was showing these heat loss curves. We love those. We were super excited when we were able to get that added to Veta. So the one on the left is the heat loss curve prior to that cold segment. And you can see the first blue point there is from the thermal profiling system. So it was around 270 degrees. And then the yellow curve down below is all the temperature measurements recorded from intelligent compaction. And so in that area there where it was warmer temperatures, again, placed at 270, compaction started around 250 to 200 degrees in the first 12 to 15 minutes. So they did a great job. And then when we got to that cold section, my goodness, it was 210 when it was placed. Compaction, you know, in general was 190 degrees down to 140. So that's not what you want to see out there. So again, extremely powerful tool that we can use to diagnose what's going on. So the last few slides here is just the future. Veta, we piloted it on a couple projects last fall with success. The e-tickets were pushing just fine. We had loading and delivery event data pushing. There's a few hiccups there. It's pretty much 95% there. And I think that third-party system, that vendor has fixed, hopefully, those issues. So there shouldn't be any issues this construction season. And we are working with some other third-party systems as well that are interested in it. So this spring, we are going to push it out on projects, 6 projects right away here, just to make sure there's no other hiccups. And then if all goes well, we're opening it up. So if you are a state that you're wanting to learn more and start using Veta, do let us know. If you have a third-party system, I know some of you states have purchased your system directly instead of through the contractor. You know, do work with us to make sure that that system has done their beta testing with Veta to make sure that they are meeting the ASTRO standard that it can push into Veta. Our current money that we got here through NRRA, we are putting towards tabulations so that we can adjust for your rejected, wasted, your paid for quantities when you're swapping out pay items for certain percentages of quantities, both for tabulations for payment purposes, but also for your testing and sampling rates. So, and including looking at that point of placement and mixed designs. And then calculations, we are going to put more transit flow rates in there, ingredient tolerances for those states that do require ingredients to be pushed through. Concrete side, being able to have that automatic calculation of water available to add, updating your water to cementitious ratio, and there's some other calculations as well. I didn't want to put the entire list here. So, and then adding some more dashboards and regional relational tables. Again, Amanda already said this, you know, part of this money is going towards converting Veta desktop to the web-based. That's your IC, thermal, and DPS. And then, you know, just kind of a reminder, you know, so we had those test devices in Veta now. But again, anything that has geospatial data, we intentionally built Veta so that we can keep adding more data. So concrete, for instance, all your vibration sensors, you know, that could be brought in. So again, it doesn't have to be asphalt specific. If you have data streaming in and it has geospatial locations, we can bring it in. So again, we were trying to come up with a solution that wasn't the full Esri solution. So, and then future, you know, we do want to bring in your GPR layer thickness data. Being able to chop it up. A lot of you are doing 3D designs. We've tricked Veta and have done the exports to bring it into Bentley and overlay it in there for 3D modeling. And so it is extremely powerful. It's just we need to clean up the data for these imports into Autodesk or Bentley. And so that's another powerful thing that we hope to use in the future as we keep getting funding for Veta to be able to bring these layer thickness information in there and then also be able to tie it right to our 3D models. ProVal, we want to bring in your ALR, IRI measurements in there and tie it to paver stops and so forth. Pave Cool, it'd be handy to have Pave Cool in here. So just a few examples that Amanda went through. And then just kind of the bigger picture. Again, we created Veta purposely to have these open APIs to allow that data interoperability. So the goal is we don't want it to stop at Veta. We want it to go to your pavement management systems, right? We want it to go into your asset management systems as well. You have both the material and geometric assets from all these technologies that we should be storing and tying it to other information. So, and then tying to these other databases that you might have or ASTRO projects. So again, you know, it's building this system so that we can share that data and integrate it with other data sets. So here's just the map of all the states that have funded Veta to date here. We have 21 of you. And so over time that's been a part of all the pool funds or one of them. So, but with that.
Any questions for Rebecca?
All right, thanks.
Let's thank her.
Okay, so you can read Dr. Eyoab Zegeye's bio. One thing I'll say quickly while I'm pulling up his slide is I'm kind of weird in the sense that I like when I find out that I'm wrong about things, because that means I'm closer to the truth if you think about it. And Eyoab is right next door to me, and I get way closer to the truth every time I talk to him because he always tells me how much I'm wrong about things. So let's welcome Eyoab.
Thank you, everyone. I'm going to keep it simple, no chart. I know it's been a long day, so please bear with me. Thank you for staying long. Before I start, though, please allow me to start with my personal note. Some time ago, by the way, I have a son who just celebrated his 8 years last Friday. Some time ago, he asked me, "Who is that guy who's always in a picture with my mom?" And then I figured out that person, it was me when I had a couple of hairs. So, and he wouldn't believe that. And the reason I'm telling you this, when I have a couple of hairs, I was doing a lot of research development. That's how I got introduced to MnDOT. I was working with the group that Ishan was also involved on research and development for cracking, asphalt cracking, where we developed semicircular bending, DCT, and others. And then I went to Federal Highway, where I met and worked a little bit with Fanien, where I was trying to help refine and promote asphalt mixture performance tester and other type of technologies. And these are very cool technologies. And what I'm trying to say is I've seen a lot of awesome technologies that they come from research and development, but then they end up dying, because sometimes the research implementation is also as important as research development. So when I came to join MnDOT, I was so happy, and I came to MnDOT with a philosophy that my main focus would be in implementing technology as much as I can. I was fortunate enough to work with very excellent colleagues here, mentors, and with that, I was also very fortunate to be working on this small unit that is called, we lovingly call Road Doctor Program or Road Doctor Unit. And the purpose of this unit is basically to introduce innovative pavement evaluation technologies to our districts and to our local agencies, and then work with them to kind of identify what are the proper applications for these technologies, but also find out or identify research gaps. And then once we have identified those research gaps, we work with our partners, with the universities, with NRRA, with other national pool fund studies to come to solve this type of problems. So today, I have removed all the charts, all the numbers. I will just quickly show you what we're trying to do in implementing this technologies, and what we're trying to do to solve some of the research gaps that we've seen. The two technologies that I would like to focus on are the 3D GPR on the left, and then the traffic speed deflectometer that we have recently started working with. The 3D GPR, we do have at MnDOT, we have 2 units of 3D GPR. This is a kind of newer technology of GPR. And as you can see, since we started with the Road Doctor program since in 2019, basically we've been getting more projects. We've been implementing this technology on more projects for project scoping. We've been almost doubling every year. So far, we've been involved in 133 projects. Thomas here has been our lead personnel now collecting data and reporting that data. We have also payment design unit with Greg Larson that we have also working with this 3D GPR. And we've been trying to, as much as we can, to work and connect with all our material and soil engineers and trying to see what are the proper applications and how we can help with them. So some of the key applications. Some of them, they are simple, but doing some research work on a lab or on a field experiment of 100 feet is completely different from applying that technology on 10 miles, 100 miles. So you need to find how to collect that data, how to scale up that application of that technology, how to process that, who is going to process that, how is that going to be integrated in the routine project scoping processes. So it took some finding, but seems like one of the most interesting application is basically finding out the layer thicknesses. And as you can see here, one of the main difference from traditional GPR is you do have longitudinal profile, but because of 3D GPR, you also have the transversal cross section of your pavement. So in this case, you can see that your pavement is a very uniform pavement with a super pave IC layer on top and an all road mix. I will come back to this slide again to show you one of the most applications. So determining layer thickness is one important thing. Once we have analyzed the data, we report that data to our material engineers so that they can use it to help with selecting what's the proper treatment or what's the proper mill depth. As you can see here, if you cut, for example, if you mill your pavement at around 13 inches, you will be cutting also on your aggregate base. So this is it helps them understanding the layer thickness variabilities on both longitudinal and transversal section. But the other, I think, most important, simple, but yet very important application of 3D GPR is also using 3D GPR images to what I call smart coring, basically to guide where to core for project scoping evaluation. So in this case, for example, this is a 1 mile length of road. In a traditional way, for example, if we are on project scoping, most of the times we will require like coring every 1/10 of a mile. That means we will be coring 10 cores on here. Coring, that means you will have to close the traffic. This is putting your operators in a safety risk, and it comes also with cost. So in this particular case, as you can see, if you had the GPR image, you would quickly see that you don't need 10 cores. All you need is 1 core just to calibrate and make sure what you see is the same. So by doing this, we're first of all reducing the number of cores. But not only reducing the number, but we are also coring on areas, on meaningful areas. This is basically like going to a doctor, do MRI, and basically they will tell you where to do the surgery. If you have a problem on your left hand, they won't be doing surgery on your right hand. So this is helping you. The GPR is basically guiding you, first of all, to reduce the number of cores, and then to core where it's needed. The other thing is also it helps you most of the times with our roads when they are ready for rehabilitation. They've been there for 40, 50, 60, sometimes 70 years. And not always we have proper documentation readily available for us. Most of the time, some of them, they are widened. There are areas they were island, and then they have been included to become an additional lane. So most of the times, we don't know exactly what happened in certain sections. So the GPR is also good because it can help you not only discover the transitions, but also sometimes finding small pavement structures that you were not aware of. You wouldn't like to be surprised during the construction. So it's good to know these things ahead. But with all this, as I showed you before, the layer thickness is a semi-automated kind of process. But if you want to look at also at very closely what else is happening in my pavement, do I have stripping? Do I have the lamination? Do I have the bonding? Yes, it can be done with GPR. As I can show you here, the GPR really have a good picture of what's happening underneath your pavement. One thing is seeing these things. The other thing is like looking at 100 miles of road and finding all these problems, all these sections visually. That becomes very difficult. It's like looking for a needle in a soccer field or football field. So visually doing this becomes very difficult. Because of that, well, as I said before, we do implementation, but also we work with our partners, with other state DOTs. I see here North Dakota Illinois, and other, to basically solve some of those limitations that we have with the GPR. One of the limitations that we have with the GPR is basically automating the process of finding areas which are damaged, like stripping, delamination, or other types. So with that, we created this pool fund study called TPF 5504. The name is very long and not necessarily the best, but continuous bituminous pavement stripping assessments through nondestructive testing. And there are, as I said, those are, if you want more details, please look at these websites. We do have the MnDOT website and also the National Transportation TPF website. I'm going to keep it simple. I'm just going to give you the highlights. We have, I think, 10 states and federal highway along with us. What we're trying to do is basically, this is a proof of concept. One is by Ken Mazer, and the other one, which we developed in-house, is basically using the GPR data and coming up with an automated way to sell that tells you where do you have stripping issues, where should you be investigating further. And stripping, when you have stripping issues, most of the times it's not only bituminous pavement. Our colleagues also in Illinois, when they have concrete overlaid with asphalt, they still have that problem on the joints. And that's the reason here. We try to cover as many different states so that we can cover different mechanism of stripping, different kind of deterioration, different kind of problems underneath the pavement. For us, most of the times it's with bituminous pavements, with full bituminous pavement, but we do see stripping and other type of delamination in all sorts of pavement. So what we're trying to do with this study is, first of all, coming up with an automated way of finding the stripped area. So make that process very easy. Once we have that process, once it becomes automated, it will become also easy to probably put it also on Veta and other type of platforms. So one of the things that we did with we have long discussions. We posted this, and then we came up with a work plan with what we would like to achieve and how we would like to achieve it. One of the things that we wanted is the software that was going to be produced. We didn't want to be an executable or a macro template that someone has to keep managing. We want someone to develop that process and then put it in a commercially available software like Examiner. So we found a team that agreed to do that. So right now we are on work of that. The team is actually is a group of team composed of Infrasense, Contour, NSC, and Hyatt Consulting. So basically, they are first coming up with a mechanism, with an algorithm to automatically find those areas and then work with Contour to put it on Examiner so that it becomes available to more states. To help with this study, what we did last summer is basically build the 12 test sections in Mill Road. And those test sections, as you can see, we basically hide or artificial, we put here, I can see here, we created artificially stripped elements and we hide them in the pavement. So the idea is to see if the GPR can find them and then come up with use this data to train the GPR data to come up with an algorithm that use GPR data, not only GPR, TSD data, impact echo, FWD data. Use this data basically to train the algorithm so that then the algorithm can be applied also on actual roads. As you can see, we're already very happy because the GPR can see these elements that are hidden. Now we're working with Ken Mazer to come up with that algorithm. Once that algorithm is ready, we have already identified several roads in all the states that are member of the pool fund study. So we will be applying, validating the algorithm on these roads. So we will have two phases. One is basically the creating, developing the algorithm, and then validating it and packaging it in Examiner software. The other technology that we are looking is the traffic speed deflectometer. As you know, pavement deflection, using pavement deflection to basically come up with mechanical properties of pavements or the strength of pavement has been known for a long time. and it's quite a straightforward type of analysis. But measuring deflection has been very challenging over the times. MnDOT has been started with measuring deflection long time ago in the 40s, when we had basically a penetration test. And then we moved to bank lamp beam. We've been working with FWD. Most of you are familiar with FWD. But lately, we've been, like many other states, we've been interested in this traffic speed deflectometer because, first of all, it basically allows you to collect miles and miles of roads, data on miles of road without traffic interruption. And it is non-destructive type of test. So because of that, as you can see the difference here, from 40 tests per location, we can basically measure continuously with the TSD. In one day, we can cover up to 200 miles, while with FWD, in one day, we will be able to do maximum 6 or 8 miles. So that's a huge difference. The TSD, the main difference is that it does not measure necessarily deflection. It measures the slope of deflection, but then it can mathematically convert it to deflection, and then you can have continuous information of your pavement structure. So we've been interested on this TSD. We've been trying to implement it in our state. We started in 2023. We explored the data on different type of pavement, BOB, BACE, BFD, concrete, reclaimed, and then lately, slowly we're increasing. This year we'll be collecting 600 miles of road on one district. What we're trying to do is how can we use this for project scoping, but also to help with our payment network management. We are also working with our partners and internally to do some research on how to use this data. We're trying to see how can we extract meaningful parameters, finding out appropriate application, and then also developing robust analysis procedures. We're also looking at estimating accuracy and precision. I believe tomorrow Soheil will talk about the work we're doing with Soheil on finding accuracy and proper application for TSD. The other work that we're doing internally is we've been repurposing the use. We have a software that was developed for analyzing, for back calculating layer modeling from FWD data. So basically, we're trying to repurpose that also to the TSD data. One of the challenges of the TSD data is because we have thousands of data coming. So we need a software that can help us analyze or back calculate TSD data, which does not have to be completely rigorous. We're trying to find a fine balance between rigor and practicality. And TON 2010, because it allows you basically to analyze data coming from 100 miles in 15 minutes, we're trying to repurpose that for the analysis of TSD data. And this paper that is published coming soon in the TRB journal, we did find some of the limitation of the current TON 2010, but also some of the strengths of the TON 2010. We're going to work with our partners and other researchers to improve those, to surpass those limitations and make sure that the TON 2010 can be also used for TSD data. Other key studies are we also working with Ken Mazer, trying to apply GPR for evaluation of concrete pavement. One of the things that we are looking at is basically looking at misplaced or misaligned dowel and tie bars. The technical liaison here is Dai. You can jump in if you want to add something. And we are also, I will do a quick plug in here. Last year we gave in our YouTube channel, in the YouTube channel, NRRA YouTube channel, there is a presentation that we gave on the work that we're doing with using GPR to assess moisture in service payments. Based on that study, now we are looking to continue on the study, and we just hired Iowa University and AED to help us implement the use of the GPR for assessing moisture in foundation in service pavement. This will be, in my view, very important to help us use GPR to tell us when is the right time for spring load restriction or when it's the right time to open a road that has been closed due to high rain. Right now, we do have good tools, but sometimes they are one solution fits all. So if we can use GPR also to assess moisture in service pavement, that will be another cool thing. So this is another project that has been finalizing. They are working on the finalizing the work plan, but it will be soon. So Kyle, this is the update of what we do. Thank you.
Good.
Sorry, I hold you long. Any question?
Any questions for Eyoab?
Okay.
Thank you.
Thank
very
you.
much. Yeah.